What if we applied like functional programming on top of this, and then we can just get every undo or every edit point that we've ever had in the history of when we started this text file. And I'll show you how that works when we open up Fred, and we can walk through the code and I can show you how everything is like. It's also faster for compiler throughput, by the way. Template instantiations are typically done at the end of like certain functions and stuff like that. And so if you sequence it in a way where your function definitions kind of come last, sometimes you can get some compiler throughput that way. It's a weird little trick you can do if you like know the compiler you're working with.
What do you do at Microsoft?
Okay.
Because I know, but you need to tell it.
Right. So what do I do at Microsoft? I actually work on the Microsoft C++ compiler. And what I do on that compiler specifically is I work on the front end. So the part that eats all the C++ and like eventually spits out code. I worked all over the place on the front end, but the vast majority of my time was spent implementing C++ modules, which is kind of like it's like a different mechanism that you can use instead of hash include. You can say like import some module name, and then it just kind of takes like a pre-compiled thing and imports all that stuff into the current translation unit. So a lot of my time was spent figuring out how the heck do we serialize C++, and then like how do you take that nonsense and like attempt to merge it with the current translation unit. And anybody who knows C++ like kind of in depth knows that that's like a ludicrously difficult problem. And yeah, so vast majority of my time is just spent debugging all of that stuff. And then I've implemented some other things like the spaceship operator or like deducing this for C++ and just all kinds of stuff. I've been all over that compiler for years and years. But more recently, I'm kind of focusing on like, what does it look like to kind of make customers a little bit happier? So, right, like how can we attempt to like guide the compiler fixes such that we make more customers happy? That's the thing that I'm currently trying to solve at work.
If it's not legal / good PR to tell this publicly, then you can say you should not say this. But I have a question regarding C++ modules and their state. Sure. Meaning, a lot of I think the whole idea with C++ modules is to address issues with include system, which is just copying and pasting files. And right. If you don't have keep a check on what you include and where, it spirals into monstrosity quickly. But the first implementation of C++ modules and various compilers was not satisfying to many people expectations. So what is the state now and how do you see this progressing?
Yeah, so I think the state of the actual compilers is a lot better nowadays, especially compilers, with the Microsoft
modules.
Yeah, for C++ modules. Especially for the Microsoft compiler, because like we were the first compiler to kind of pioneer the module space. So our implementation is a lot more mature, but the other compilers like GCC and Clang have caught up significantly. And so like, why aren't we seeing modules everywhere? That's kind of I think that's kind of like the salient point you're trying to make. Like, why are we just not using modules everywhere? And the answer to that is really just the tooling ecosystem around it. For example, to build modules, you have to construct a different kind of build graph. Like you have to figure out what are the interface dependencies of this translation unit, right? Like you can't do the embarrassingly parallel thing where you just go fire off 1,000 compilers and a bunch of C++ files and magically you'll get a binary. You have to kind of stage things now. And that's actually the thing that's stopping a lot of the adoption efforts. Because if you don't use a build system or like a configuration system like CMake, CMake plus Ninja or CMake plus MS build, you're kind of left like implementing the build graph yourself. And so the compilers give you the tools to build that graph, but you have to do it. Like that's the problem.
Okay.
Yeah. But in terms of the implementations, they're very solid nowadays. Especially Clang. Clang caught up quite a bit because GCC was like kind of almost there with Microsoft for a long time, and then Clang was like really far behind. But recently, a lot of people like I know we have like an implementers meeting from time to time where I talk to like Clang devs and GCC devs,
okay.
and Clang has been going gangbusters on modules, which is great. Like they've been putting in a whole bunch of effort to make things work.
Hi everyone, let me take a break to thank members of the show who made this conversation possible. Members get earlier access to videos, including longer unedited footage from live streams, as well as they're invited to our private Discord server. If you want to support the show, there is no better way than becoming a member on YouTube or Patreon. Thank you so much.
That's nice.
Yeah.
It's
good.
Recently discovered, because I was doing things primarily for Windows and then MSVC, and then like I was using Chrono, and then I realized that Clang is like, no, that's like empty there, and I needed to step back and do like a portable solution. But that's fine. This is the first time I realized that like, hey, standard is one thing and your C++ version is one thing, but then depending on the compiler, then it's like you need to understand what's there for a given thing.
Exactly. And like modules, like people want modules to kind of they want them to increase their compile times, because like C++ is notoriously horrendous with compile times. Like literally, you were just talking about Chrono. When you hash include Chrono, that includes so much stuff in the standard library that like it'll probably take your compile time from, what was 0.5 seconds to probably about 2, 3, 4 seconds, depending on what compiler you're running with. And it's like just including the thing. You're not even using it, right? You haven't instantiated any templates. And like that's just a huge problem that modules are hopefully going to help solve. Now, there's this kind of maybe delusion that modules will solve all of the problems, right? But like when you're talking about C++ templates, modules don't shield you from that. Like the compiler still has to instantiate that thing. And so that's actually where the vast majority of the work happens to be, is instantiating templates, specifically stuff like Vector. I mean, Vector has something like 100 some member functions. So every time you instantiate that with a different type, it blows up into this huge class that the compiler has to like reason about. So that one's pretty bad. Stood pair is kind of bad. Like it's like such a simple thing. It's just a pair of two things, but it has like 30 some member functions that all have like SFINAE conditions. SFINAE, for those who don't know, is substitution failure is not an error. So like it evaluates like a compile time expression and then determines if that member function is usable. That's the idea. So it has dozens of those things. Okay. So for every instantiation of pair, you have to do that.
That's painful for everybody who was working in a more modern language, got used to things like, there's like functional-ish solutions where you have something in an array and then you map, like apply some function and blah, blah, blah. And it's like, oh, I want to add something. So I make a pair out of everything, right? I have this thing that I started with and then I add like a result and then I continue with this process with this pair. So like all of these assumptions you need to lose when you go to C++, because like, no, that's not what you want to do. You want to do like the C style thing, because like the C++, it's like...
Exactly. And as we'll see with Fred, I've architected the code very specifically to avoid a lot of those instantiation problems, because I have to have a fast compile time. Like you have to have a fast compile time if you want to iterate very quickly on something, especially something as complicated as an editor that's native. And so like I managed to get my compile time down to about like 2 seconds, which is still pretty long. But like for a C++ project that's, about 100,000 lines of code, that's not too bad. That's tolerable. It's within the range of tolerability for me.
To compare this with precompiled headers on 250,000 lines of code in one of the projects at my work take 5 minutes, because it's like not at all like, optimal.
Yeah, and it's like it again comes down to like how many C++ files are you kind of like spreading all over the place, because it turns out that like when you do a Unity build, you save a ton of time with sharing stuff like vector instantiations, for example. Because if you had that as two separate files, then the compiler has to spend time to instantiate like vector with like all these types and vector with all these types. Whereas if there were one translation unit that were unitied, you just do it once, right? And it turns out that that saves you end-to-end time. Because one, that's front-end time that you spend, and two, that's linker time that you don't have to spend doing like comdat folding or anything like that. So it's just crazy how much time stuff like Unity builds can save you if you do it right.
All right. I think now is the perfect time to transition to Fred editor. So,
Okay.
can you paint a picture? Why did you start working on Fred? What is Fred? And then we can go into like a screen sharing session and show us around.
All right, so I'll start with the inception of Fred, and it really came about because I love using editors, and I like editors that are very helpful for my workflow. So back in 2023, the early 2023, I was using a slew of different editors for different things. Like I was using Vim on the command line for different things. I was using like Notepad randomly for some stuff. I was using VS Code. I was using all these different editors to like fill a specific niche. And I was like, well, this sucks. Like I want things from Vim. I want things from code. I want things that are just simple, like from Notepad, right? Like, can I just have all of those things at once? Is it possible for me to do that? I just looked around for a couple different editors. Like, I think at the time Helix was just starting to come online, and I tried it out, and it was okay. It just kind of was like basically VS Code with a little bit more minimalism at the time, which is fine. But it didn't really fit the niche that I needed. So I needed an editor that could traverse thousands of files at once, because at work, we have this suite of tests for the compiler, and that test suite is literally hundreds of thousands of files, like thousands of C++ files that the compiler goes through, tries to compile, and like gives you some kind of result. So I need to be able to like pick through those things very quickly, take one out and start modifying it and its associated like test environment. And then I also needed an editor to work on the compiler itself, which like VS Code is pretty okay for, but it uses gobs and gobs of memory, especially when you're talking about IntelliSense, right? And then I use like Notepad for very simple things. Like if I just need to make a very quick test case, sometimes I'll just use Notepad to kind of like throw it together and get it working. But it'd be nice if I could just have one editor that did all of that stuff. And so I slowly started working on what would be Fred back in 2023. And this is like, I think it's somewhere around February. Here, I could actually look at the commit log. So if I look at log, April 23rd. Okay, so April 23rd was when the initial commit happened. But I started working on it locally a little bit before then, like probably about a month before that. So April 23rd, 2023 is when that like first commit.
So it's like anniversary because it's 26.
Yeah.
It's like, let's say it's anniversary.
We're very close. We're very, very close. It's like, and I kind of have like a special thing for Fred's anniversary at this point. So,
okay.
Yeah, it's good. It's kind of prescient of you to bring that up. So yeah, back in 2023, I started Fred. And so I was like, all right, I need at least to be able to traverse all these files very quickly. So I needed a file explorer that can like poke through the file system and get to things very fast. And so I started working on that. Everything was working. I needed an editor that can like go through and start editing code at any point very quickly. And at that point, I had a really dumb implementation. It was like a giant string that it wasn't even a gap buffer. It was literally a giant string that I would like bit shift whenever I needed to perform insertions. Okay. And then for syntax highlighting, I used a really like crappy lexer that I threw together. I just wrote lexer, and it lexed the entire dang thing every single time you did an insert. I eventually got that down to where it only lexes like at that point and then forward. So, because that's all you really need. However, as you can very well imagine, a giant string doesn't work for very long. And that's when I really started cracking down. I was like, okay, I can either abandon this thing and like just go back to whatever in the heck editors I was doing before, the different editors approach, or I can really take some time and focus on what can make Fred very different from the other editors that I have. Because that's another thing that really kind of annoyed me with other editors is like their undo systems is like very linear, right? So when you do an undo and then you start editing again, you can't get back to that point from when you came from. Like it starts a new branch essentially, and so like the other edit point's completely lost. And I know there's stuff like Vim Tree that sort of address that, but it's like a plugin, and like sometimes it doesn't quite work all the way because it just works by storing like the edit commands. So in some cases you can't get there if you push like dot period, for example, which does crazy stuff in Vim in a lot of times, in a lot of cases. So I started FredBuff, which I don't know if you want to post the link to that, but basically it was this immutable text buffer that's based on the data structure that VS Code already uses. So they use this thing called Peacetree, which is a very efficient way of storing the text. But then I took it a step further and said, okay, what if we applied like functional programming on top of this? And then we can just get every undo or every edit point that we've ever had in the history of when we started this text file. And I'll show you how that works when we open up Fred. And we can walk through the code and I can show you how everything is like assembled. But it's pretty interesting. And it it actually has saved me quite a few times being able to like go back to a specific point in history. I'm like, holy crap, this test worked here. And I completely forgot what I did. So I'll just like zoom back to that point in the graph. And I'm like, oh, okay, that's what I did. Tear out the piece of code and put it in where I had it originally, or where in the place that I was working at now. So it's pretty cool. And so at that point, I was like, all right, I'm all in on Fred. Let's keep going. Let's see how far I can take this thing. And so since that point, we've done FredBuff. We've done this whole new widget system. I've done the paneling system. I've done the plugin system, which is equally as interesting. And I just finished the Find All widget, which is like a very hyper-threaded way of like finding text across your entire project. So that's pretty much like it. Like
Nice.
And I did present it once at like Handmade Cities. Just kind of like a brief overview of some of the motivation that I just talked about. But then, yeah, talking about some functionality of Fred. Oh, there was one other thing, which is that multi-cursors are a huge thing for me. Like, I have to have multi-cursors. Okay. And Vim doesn't have it, right? Like, for whatever reason, Vim just still doesn't have it, even with NeoVim. I mean, they have plugins to sort of, like, hack it in, but it doesn't quite work. So I had to make multi-cursors like a first-class citizen of Fred, and that's what they are. And it works really, really well. So,
okay,
happy about it.
Now I'm excited about multi-cursors to see like how first class can you get with multi-cursors. Because in NeoVim, it's like, or Vim, it's like this awkward Control V thing when you're like doing things and like repeats for other lines. It's just like, But yeah.
Yeah, exactly. And even it's all the way down to even the plugin system. The plugin system works with multi-cursors as well. Like you can make a plugin do like something specific with one of the cursors, but not the other ones, for example. And so like that's the kind of power I wanted to be able to give to people. Like if they want to just make an editor command that does something wacky, like they could totally do that.
Okay. Is this the point where we get to see the Fred in action?
Okay, yeah. Let's definitely do that. So how do I share?
By the way, there are people already in the chat. Where can I download? I wanted to ask this in the end to be like, what's the state of the project? But maybe we can sneak in this question now. I think people are popping into Discord as well. So
yeah. So right now, I have a website called freddev.tech. There, I have a link. I have a link to my Discord server, and from my Discord server, you can get binaries for Fred.
Okay. Is it like a intentional way not to have it online, like on a website, or
Yeah, kind of. It's like
is
I
it like
wanted to.
join the group or cult? Join the cult.
Yeah, it's mostly so I can try and have some kind of like feedback loop with people who are
Okay.
trying Fred. Because if you offer like a download link,
Yeah.
one, you don't know who's really downloading it, which maybe who cares. But the more important thing to me is that I try and get some feedback and like iterate on the problems that make Fred hard to use. And so the Discord server is currently like an okay place to do that. I wish there was a better mechanism. Like maybe I probably need like an actual issue tracker on GitHub or something like that. But Discord seems to be working pretty okay for now, just given like because Fred's kind of small, and so it just seems to work.
So people, you are obligated. Whoever downloads the binaries for a thread, you're obligated to leave at least like one sentence message feedback. Okay.
Yeah. Even if it's like this editor is awful, like I don't ever want to see it again. And it's totally fine. Like if people try Fred and like say it's an editor that's not for them, that's completely reasonable to me. Like I'm not expecting people to you like daily drive Fred. It's a very kind of like some of it's like kind of specialized. It's all based on like problems that I had to solve for myself. So that's the whole idea.
I think
Okay.
that's a good way to go about the project. Like you have a vision and you go through with this vision instead of trying to like satisfy everybody who is doing like different things and
Yeah, exactly. So that's kind of the goal. Okay, so should we try and build Fred? Is that the idea?
yes.
Okay, so if we try to build Fred, you'll notice a couple of things happened. One is we have this asset tool here that takes a bunch of assets, compresses them, and then like embeds them into the final binary. So this is kind of like our meta tool that runs. And then after that, we have our main Unity build that builds the entire editor. And all of these are like annoyingly tree sitter stuff. You can't Unity build tree sitter, unfortunately, because of the way that it's like kind of because of the way that they generate their code, they use a whole bunch of the names like static functions that overlap with each other, so you can't like Unity build them at all. So they
Okay.
have to be built as separate objects. But free type you can Unity, and TCC, which we'll talk about later, because that's an interesting thing. You can also Unity. So that's it. That's all it took to build the entire editor. So if I
Nice.
you can do we can try it again, just see how fast it is, right? Like,
We're
and that's
flexing with the like 2 second build.
yeah,
Nice.
that's building everything. Now, normally what I do is I use build no depths Fred, and like this is typically how I iterate. It just builds the editor. Like that's all I care about. And
Just
you could do
editor,
like,
meaning no tree sitter, no free type, no TCC.
yeah, nope, no, none of that stuff. Because all those things are already pre-compiled objects that are already on the disk, and I rarely touch them. So no depths is a really good way for me to like kind of bypass all of that stuff. But you can kind of see good cancel. You can kind of see like this took 3 seconds. I think it's probably because maybe I'm streaming and there's a whole bunch of stuff running in the background, but like generally it'll take between 2 and 2.5 seconds. Yeah, I don't know why that's so long right now. But that's typically the kind of thing. That's typically the kind of compile time you expect, especially if it's like just focused on this thing. So this is another piece of Fred tech, which is like how quickly it starts up, right? Like it needs to be pretty much like instant. And we'll talk through what actually happens when you start up the editor. You'll notice in the bottom right hand corner or bottom left hand corner here, there's a whole bunch of stuff that happens. Like we load some hotkeys, we compiled something, right, in 1 millisecond, and then the shaders were loaded and all that fun stuff. But just to compare, like Notepad starts up pretty much instantly. Fred kind of starts up roughly in about the same amount of time. And note, this is the debug version of Fred. Like there's no optimizations here. This is all stuff that's just running by itself.
Nice.
With no code optimizations whatsoever. So having it be fast at debug in like a debug build is pretty essential for me as well. So I prepared this fredarch.txt file.
Ooh, nice.
Yeah. So this is kind of like, I kind of took all the files and I broke them down into essentially 3 big buckets of stuff where this is kind of like where the pieces of Fred live, and like this is kind of like architecturally where they fit into the editor.
Can you increase the font for the stream?
Yeah, I absolutely can.
Look at this, Fred, flexing with font increase.
Is that big enough, or should I make it larger?
If you can even larger, I think it's gonna be appreciated. Nice.
Yeah. So there we go, and you can see like the widgets and stuff like scale as
Nice.
well. So these are kind of like the 3 big buckets. There's what I call UI, so like anything that is presented to the user. There's Fred core, which is all the Fred specific stuff. So this is like the text buffer. These are all the assets that are baked into here, like some various like utility stuff. And then of course the plugin system. And then there's core, which is something I share with multiple projects. It's not just like specific to Fred, right? So we got like arenas, strings, the operating system pieces. I know this says Fred core, but it's really like shareable stuff. Same thing with Fred strings.
Okay,
it's
that's
all
marketing.
stuff.
That's marketing. You have this across your project. It's called Fred.
Exactly, right? That's where it came from. That's its origin story. And then we have our external libraries, right? So I only use 3 really big libraries, right? I use FreeType, I use TCC and TreeSitter. And I guess like mini Z for like compression and decompression. Like that's just like a really nice minimal library to use. But TreeSitter, FreeType, and TinyCC are kind of like the large libraries that I've integrated. Everything else is like super small, very kind of like basically I could replace it with my own code at any time idea. And then there's the unfinished bucket, unfortunately, which is FredProj. I have started this and scrapped it 3 times now. So that's why it's like going to sit there for a little while. And
is it the concept of a project in the editor itself?
Yeah, exactly. So if you've ever used 4Coder has like the 4Ed project, where Alan has done, by the way, Alan, I have to give a huge shout out to Alan because he has helped me really develop this editor into something that is like actually usable for multiple reasons and like architecturally makes sense. I've talked with him in depth quite a few times on like various, like how to architect certain pieces and how Fred is constructed. Like you had that interview with Alan. Yeah, everything he said about 4Coder is like spiritually here in Fred.
Oh, really? Okay.
Yeah. So, if you want, we could start diving into various pieces of Fred. Like we could start with the UI layer or like...
Can we do like a bit of a overview from the user perspective? So like editor itself. For example, you mentioned multiple cursors and stuff like that. So that kind of we have the idea like where is this, where is it? Where is the text editor at in terms of the featureness or like comparing this to some other editors that we use every day?
Right. Okay. Yeah, that's a good point. So I'll kind of start with like when you're typing with Fred, the idea is that input latency has to be extremely, extremely low, which is why, well, let me switch this to C++ and then turn on syntax highlighting, which is why like I've gotten this feedback quite a few times actually that like editing in Fred is it feels very responsive, and that's completely by design, and that's the way that the editor itself processes like input. It takes this really interesting priority to certain events that contribute to seeing text on the screen very quickly. And so that's part of the reason why like Fred is so responsive. But also, let's talk about multi-cursors for a little bit, because that's the first class citizen thing that I was talking about. So if I have like an int array here, and I have like something like this. By the way, there's a Vim mode, and I'm always in Vim mode because
I can see
kind of
that.
use a lot of Vim motions. Yeah. So let's say we have like something like this. Like it's like 9 and then 10. I'm intentionally leaving off the commas because we're gonna fix all that. So with the editor, with the multi-cursor support, you can kind of do something like this, where you can spawn a whole bunch of cursors at once,
Okay.
or you can kind of go down, right, and like have them go wherever you want. Typically, what I do if I'm like doing something like this, where I need to add a comma, I'll just spawn them using the Control Shift or Alt Shift and then click, and that kind of just from where your cursor is, it spawns a whole bunch of cursors going down. And so now you can just do it like that. And so the other interesting piece about multi-cursor support is that you want it to be intuitive with undo. So if I hit undo right now, the expectation is that all of those commas disappear. And so like that's kind of what happens, right? Although the 10 disappeared because that was the last insert, unfortunately. But the idea is that all the commas disappear, right? So hitting undo, boom, all the commas are gone. And if I hit redo, like they come back, right? So that's kind of the idea. And then additionally with multi-cursor support, you can do something like you can put in like another column there pretty easily, right? You can align them over here, and then like, I don't know, let's make another column of, I don't know, 12, something like that. And then if you need to get rid of the space, you can do something like have them extend over here and move it this way. The other piece is like how when you copy lines or when you copy text, what you actually want to do when you have multi-cursors is associate that selection or like that copy with that specific cursor. So if I have something like, let's actually get rid of this stuff for now. So if I take these numbers and I copy them all, like let's select the whole number. So I copied them, right? When you go to paste them, you get the numbers like this, right? And so when you have a single cursor, it just inserts all of them as if like every single multi-cursor inserted its text and then a new line after that. But something interesting happens when you have an equal number of cursors selected. So if I have 2 cursors, it just repeats the same thing, right? That's actually a weird expectation that not a lot of people think about. However, if I have an equal number of cursors, so like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it inserts it 1 to 1
Wow.
because you have an equal number of cursors to the equal number of selections. And so like that's a very special case of multi-cursor support that not a lot of people think about, but it's like it's really intuitive when you use it. Like it's actually super useful when you have that ability. And like I said, if you have fewer than 10 of them, you just get each cursor copies the entire selection to itself. But it's like special cases like this that makes multi-cursor support a little bit difficult. And like if you're not thinking through all of the problems, you might like run into weird issues. And stuff like word deletion is really weird. So like if I delete a word, they all like collapse into one cursor, right? Because they start overlapping, and then you just want a single cursor at the end of that. So that's the kind of interesting stuff you can do with multi-cursor support. And there's all kinds of stuff you can do on top of that. Like somebody wrote, or so this person on our Discord, Professor Sill, he wanted like kind of an interesting plugin where if you have a cursor that's like, say, way out here, you have a cursor that's way out here, but you want to like, let's say you want to add some kind of comment like this for all of the other cursors. Let's go ahead and zoom these out here. I want to have I want to align all of these cursors to like this bottom one, for example. Um, there's a plugin he wrote for that. Align cursors with or align multi cursors with spaces. And so what it does is it takes
Wow.
all the other cursors that are beneath that and inserts a space for them. So if I hit that, I got to be in insert mode to do this. If I hit that, look at that. They're all aligned exactly where you expect them to be, right? Boom. Pretty awesome, huh?
I think I met Professor Sill. I'm not going to disclose his name, but in real life. So I have no. For me, it's not a surprise that he would go to achieve. How do you say this in English? To go like far lengths go lengths to achieve what he wanted. I don't know what to. There's a very very nice way to say it in English, but I don't know how. But that's a nice. And the fact that you have plugin system so low, like the plugin system exposes API to do such things, is crazy. It's great.
Yeah. And like here, we can actually go and write a really quick plugin too. So like let's plugin.c. So like this is the plugin file that I compile personally. It can point to anything. The editor can point to any .c file and try to compile it as a plugin. And we'll go over that. But this is kind of cool. But just to quickly show you, here's the align cursors with spaces, right? So like this is the code that actually drives that behavior that we saw earlier. And you get, we got scratch arenas like in our plugin system, right? We got all kinds of fun stuff. Like there's some built-in commands that you can use, but we can actually just write a really quick plugin right here. Like let's say f plugin like this. Gosh, it's awesome.
That's your most needed plugin in any editor.
Exactly. We'll even name it Wookash. How's that sound?
Nice.
So if I go editor, CMD, CMD equals 0, right? Whoops. We're gonna make a little editor or command. Insert, and there is like a autocomplete thing, which you notice maybe. So there's some really like very primitive autocomplete stuff that happens in Fred. It's kind of something close to what default Emacs would do, where essentially it takes words and it tries to convert them into a suggestion list. That's basically all it does for now. But later it'll do more interesting things. So we got string 8. Let's go ahead and insert kind of an interesting. Let's steal like this header, for example.
Hell yeah, ASCII art, baby.
Yeah, we'll do some fun ASCII art here. Let's put this here and we get rid of a whole bunch of this stuff. So we have this, and we'll insert like. I'm just gonna steal more of this stuff here.
While you type, I wanted to like highlight when you have multi-cursor support and Vim motions. This is like superpowers, because like everybody who's using Vim motions, myself included, like spends some amount of time to understand like what is the optimal key sequence to hit to actually do what you want right now, given you have to cursor this and you want to go to there, and you have this like effort that you exert to actually do this in your mind, and it's like, now do this for 10 lines, bam. It's like so useful. Because
Exactly.
because in Vim you can't really do that normally. Like you have this Ctrl V and then you go Shift I, and it's like now when you insert and you escape, oh, you missed something. Now it's like you need to fix it. It's like
Yeah, it really is like a game-changing experience when you have like Vim motions plus the ability to multi-cursor plus the ability to write like plugins like this very simply. There's a bug here, and I'll show you why once we try to execute it. But that's kind of it. Like we're just going to insert this little buffer, right? Let's see if we can get it to compile. So from this command palette, you can execute any command, but you can double click it here or just hit enter, or you can hit Shift F1. So if we hit it, look at that, our plugin compiled. So now let's go to our text file here and try to use it. So if I do like, if I look for Wookash, let's see. Oh, I need to actually add it. I need to bind it. So it has to. You have to tell the editor like what functions you want to bind to, and so you do that by adding a custom binding to ed here. So we can do like, I think we named it Wookash. Yeah, that worked. Okay. So now if we go to Wookash is awesome.
Nice.
There's some new lines, right? So let's undo that.
That's artistic, though. That was artistic.
Yeah, exactly. So let's add our multi-cursors, right?
Yeah.
We can do new line. And so compile, boom, just like that.
You don't do /r?
I don't.
But you work at Microsoft. You should do /r.
We don't want any CRLF here. Fred does have really good. It does have really good support for that, though. It has very good support for CRLF. Annoyingly, right? Like anybody who's written an editor will tell you that supporting CRLF properly is annoyingly difficult.
Nice.
There you go. How cool is that, right? And that's a plugin that we just wrote, in C.
Yeah.
And it compiled instantly, right?
Yeah, without quitting the editor. That's so cool.
Yeah, all from inside the editor, we were able to do that.
Nice.
And you could do way more interesting stuff than that, obviously. But you got your ASCII art.
Okay. All right.
Yeah,
awesome.
and that comes from this piece right here, the whole plugin API, the plugin system.
Yeah. So you mentioned that the project's like the project concept is on the to-do list. Can you speak a little bit to why? Because for many code editors, they kind of all jump immediately into like, oh, this is an IDE. Now we want to have a project, and now we have a different repository. It's like, oh, no, it's a Git include. It's like everything kind of spirals from there. And, you're there like, no, let's put this off a little bit.
There's a couple of reasons. The biggest reason why the project system is kind of on hold is because I've never been satisfied with the result that I've been trying to produce. Like, I'll get to a point where the project system is almost there, and then I'll be like, this one piece just like, it's such a deal breaker that I'm going to scrap the whole dang thing.
Okay.
For example, like I want stuff like go to definition. And sorry if I'm kind of like looking over here because I got the stream over here, but my camera's over here.
It's fine. It's okay.
Let me know if I should shift the camera. But anyway, I got to the point where I got go to definition working, but then everything else underneath it was just kind of crufty. And that's not really what you want for a good plugin system. And so like I scrapped that one, and then I had another one that had like an early version of this plugin system. It wasn't even using TCC. It was actually using Lua. But I just didn't like Lua. I hated the indices started from 1, right? Like that's such an annoying thing when you actually go to write plugins. Like you're just crashing all the time. And like Lua's like, what are you doing with this 0 index crap? That's actually, it was so overbearing to use 1 indices that I simply could not use Lua. I'm sorry to anybody who loves Lua. I couldn't do it. I just couldn't do it. And so at that point, I was like, all right, let's scrap this thing. And then I had the latest version, which had kind of find all built into it. We have a find all widget now. But it had find all built into it, and it had like a nice project explorer and stuff like that. Kind of similar to what you see here. If you push this little anchor thing, this thing flattens all the directories and like kind of gives you a view over the entire projects or over all the source files. And I really like that. but I couldn't easily fit the way I was architecting it. I couldn't easily fit something like go to definition in it very like very sanely. So I scrapped that thing. But there's one good thing that comes through all of these iterations, which is that, I have it gave me muscle to like build up the other widgets. Like right now, the File Explorer has this functionality to be able to flatten files because I went through that exercise. And like the Find All widget exists because I went through the exercise of doing it, or like trying the project system and failing. And the same thing with this modern plugin system, like what I have now. So it's like basically taking the learnings of things that didn't work and scrapping those and taking the ideas that did work and actually integrating them into the editor and in a still useful way that doesn't involve projects.
Nice.
Yeah. So hopefully the next iteration of the project system will be something that's actually good and like satisfying to me. The biggest thing is like still go to definition. Like a lot of people just want that, right?
So your process for doing those things is like, let me tackle this and like try out how certain things would look like directly in the editor. And then you take things that you like, you remove things that you didn't like, and you either like keep the original idea or not, but like take the learnings from it, right? Is this correct?
Yeah, that's absolutely right.
Okay.
Like that is the basis of like how a lot of the widgets kind of evolved, right? And like that's still it's independently useful functionality outside of the project system. And that's like a really useful thing to that's a useful thing to learn out of trying something, failing, and then, keeping the good bits. I really encourage that for anybody, on their projects. If they hit a roadblock, like just take the learnings out of it, like extract the useful things and apply them to other places that make sense.
Nice.
I even do that at work all the time. Like I've scrapped so much. I've scrapped terabytes of code at this point.
Really? That's the ability to let go is a good feature to have, to skill to acquire, I think.
Yeah, exactly. Don't get attached to your code. I mean, it's just code, right? You can always go back and revisit, your old code in the Git history, but like I'm not super attached to it in that way, which is why, I'm more interested in solving the problem correctly than I am keeping the code around for posterity.
Nice. Is this then the time where we take a look at the code?
Yeah, absolutely. We can take a look at the code. So let me close this. So maybe it makes sense to start with like just the main entry point. Oh, one other thing I wanted to talk about actually was parser.c. If I go to this one, so this is like a huge text file, right? Like this is 636,000 lines of code.
Okay.
This is 636,000 lines of code. But one thing that Fred is really good at is just kind of like navigating this huge thing, right? Like I can jump to, line 500,000 if I wanted to. Boom, like it's there, right? But the bigger thing is like incremental search is super fast. Like it's instantaneous, right? And that is debug code. Like that being able to have incremental search be that quick is extremely essential for me because I work on repros at work that are like millions of lines long. Like this is the closest thing that's like millions of lines long. But it needs to be able to find everything. And it finds every single one of them, right? Like some incremental search engines in certain text editors will find the first one, and then when you hit enter, it'll find the next one. Hit enter, it'll find the next one. This one finds every single one of them all at once. And it does that by like chunking up the text file into pieces and like serving it out to threads that have like a really efficient way of searching over the text. It uses like a Boyer-Moore horse-spool searcher. So
say the name again.
It uses a Boyer-Moore horse-spool search.
Okay.
So it's kind of like this. It's kind of like this longest prefix search that like uses an array as like your index, and then like kind of jumps back in the array and tries to find like the longest prefix after that. So it's a very efficient way to search incrementally. But yeah, and you can even have like a noisy search results. There's a whole bunch of, by the way, this is the config explorer where you can like modify things like the font color or like the background color, right? Like we can change it
Damn.
and it's like reflected instantly, and then you can like go back to the original color if you want. But the config explorer has all kinds of useful stuff, and you can fuzzy search for stuff like debug, like what are all the debug things, right? These are all the flags that correspond to debug stuff that you can look at. And I ship this stuff, so if you want to look at it, you can totally look at it. But you know, it comes with a caveat of like, you might get some crazy output. But with the incremental search, like F, right? Like it shows you what each thread is doing, which is kind of
Oh,
nice. I mean, yeah. So it shows how long the search result took on each thread, and like how long it took them to join all those results, and like how long the actual search result, like 23 milliseconds, right? It's almost frame time to search
yeah. That's
nearly a
wild.
megabyte of text, 20 megabytes of text.
It's wild.
Yeah. Very useful thing. Incremental search is highly important to me. Okay. So we can we can take a look at the rest of the editor.
We can either already jump into code, but we also didn't touch on the syntax highlighting. You started to mention that like there's a find all, and you mentioned people would go to definition. There is like code completion, but it's not like LSP running in the background. So maybe we can sort of highlight how those features, like editor features, work high level from the usage perspective, and then we can go like high level architecture in the code stuff.
Yeah, definitely. So the way that syntax highlighting works in Fred is that it's all tree sitter based. So, and this is actually kind of a nice thing that I ship with the editor as well, which is the ability to look at the tree sitter output. So if I hit F11, you can actually look at what the tree sitter output looks like, right? So like these are all the nodes that tree sitter will end up creating for you, and it's like huge, right? Typically it's like huge. Sometimes you'll get errors like that. But the editor uses these like it iterates these trees and finds where the tree the start points are for certain like constructs that it wants to highlight, and then it highlights them based on this like kind of query file that I assemble. But right now, like, so for size type here, so this is a type def, and here's the declarator, and here's the declarator, and here's the type. So this is corresponds to this guy, right? And then we have the type identifier and then the declarator. So the editor is going to like traverse this at line 1 and then like column 26. It's going to say like, hey, this is a declarator for a type def, and I'm going to color it with like this specific kind of color. And all of that stuff it's kind of denoted in the config file. So I hit Control F9 to open the config file. These are all the things that you can use to customize Fred to whatever you want. And so here's like editor highlights, for example. This is just TOML, by the way. If you're unfamiliar with TOML, it's a super straightforward format. But I wrote my own TOML parser to kind of like get through the basics of, hey, you know, here's all the things that Fred supports, right? And we can look at that later as well. But here's like kind of keywords, and they're all grouped under this one color. So like anything that matches this kind of query. So like keyword.directive, here we can look for type identifier, type, or I guess there's type qualifier as well. Yeah, some of them don't quite match exactly because it depends on like what you have it declared as in the query file itself. We can look at that a little bit more in depth later, but yeah, the idea is that it uses tree sitter behind the scenes, matches to a query file, and then matches against one of these colors that you see in the config file.
Nice.
And then find all is interesting because if I have, here's the find all widget right now. If I unanchor this, Right now, it will only search buffers that you have open. So if I look for an editor, for example, here's all the results that you can see. So it found 132 results in one file, and that's because there's only one file that kind of has like stuff. If I did Fred, it might work a little bit better. So let's go ahead and try Fred. So in Fred, right, we have that in our architecture file. If you click it, it just kind of like opens up a new editor and highlights the word that it was.
Nice.
So it's like a super useful thing. But also, it gets a lot more powerful when you open it in conjunction with the file explorer. So if I root this to the directory, and now I have all these files that potentially I want to search, now I can do something like editor.
You're
and now we
gonna
have
search
like
in all of
27.
them?
Yeah, it searches every single one of them in parallel, right? And it does it in, 80 some milliseconds. Every single file that was just open.
Damn.
And here's the one I showed on like my Twitter, which is like, we found 14,000, 21 results and 450 files, and we did it in like 100 milliseconds. And keep in mind, this is still a debug editor. Like I haven't even run compiler optimizations yet. This is all debug code. And you could do that like instantly. So find all is extremely powerful when you start attaching it to, the directory. And the way that this is architected, this is the most modern widget I have. The way that this is architected is like, it uses like this kind of massive threading system, which has attached to each thread like a concurrent queue. So the UI thread can continuously pull results as they're available from the rest of the threads. Yeah. So that's why it searches so fast you can't see it, but there's like a tiny little progress bar right here that like fills up.
Yeah.
And so like when it turns green, like it's done searching for everything. But you can like match case and stuff like that. It's pretty instant. It's really good. It's a good search system.
Wow.
Yeah. So those are the other things. What was the other thing I wanted to show?
Completion. You mentioned.
Oh, completions. Yeah. Yes. So completions work. Again, they're kind of like style, or they start out in a similar way as like Emacs does, where it does like it tries to extract all the words from the current file and like any files that you have open, and constructs or serves up all of those words as a suggestion list to the current edit. So if I have something like editor, right, it does like a fuzzy match for any word that's in this file that looks like editor, right? So then now you get down to like the least likely matches, but it gives you pretty good suggestions most of the time. Like this one, I mean, that's exactly what I want, right? Like, and then if I want CMD, right, you can look through like the set of suggestions that it has there. It's extremely primitive, but it's actually just enough for what I need to where when I'm editing Fred, like like most of the time I'm reaching for identifiers that are already in the file. So I don't really have to bother like opening up a whole bunch of other files or having suggestions propagate across different files. It's just good enough for me to have, suggestions that are local to this one file. Let me show. I haven't even showed the undo system yet, and that is like kind of the premier feature of Fred, right? Let's try and showcase that. Okay. Oh. And let's syntax highlight this real quick. Okay, so let's say I do like printf, something like this, right? And what you want is like you have this hello world, but let's say you wanted to change it to hello Fred, right? And then you're like, wait, I actually kind of don't want hello Fred. I want hello Wookash right there instead. And you were like, wait, what was the edit that I did before this? What like, how do I get back to that? Because if you hit Control Z and you hit Control R, which is like undo and redo, you get back to Wookash, which is maybe like not what you want, right? Like I wanted Fred. Well, okay, let's keep going back. Nope, that's not what we want. Okay, all right, I can't get Fred, right? But what you can do is you can hit Control Shift Z, and it opens up the undo graph. Exactly. And so what's the most intuitive way to view like deltas between edits? Like that it's diff, right? Like diff is the thing that you want. So when you're navigating this undo graph, it populates it with like, oh, okay, here's the edit that you just did before Wookash. So when I hit Control Z, like undo, it would go to this state. So it would delete this printf Wookash and it would insert hello and then just exclamation point, right? But now I can go back to the original edit. So you can see it deletes Wookash and inserts Fred, and we can go back to that, boom, just like that.
Nice.
And you can keep going back to the beginning of time, like let's delete everything, right? Oh, okay, I don't want to do that. Let's go back to hello Wookash.
Wait, does it? So if you go back in time and you start typing, you start to create a new path?
You do, yeah. So let's say I wanted to go back to just this return, right? Like let's delete the printf right here. Let's actually return 42 instead, right? So now this is what our undo graph looks like, right? So now it's kind of like, I probably need to improve the UI a little bit, but the idea is that it branches off into these two different paths, right? So the one where I did 42, and then the one where I returned 0 and started doing like hello world.
Yeah.
And you can jump to any one of them at any time.
Is there a limit to like how many of the tracks, paths can there be? Like, because I can imagine like you work for a day doing tons of edits. What about the undo buffer?
That's the beautiful thing about these pure functional data structures. Every single one of these edits is only 2 pointers big. That's how big the edit itself is. So you can have thousands of these things and still not exhaust your memory.
Okay.
So every single edit's only 2 pointers big. And so I've never run into a situation where I actually like am using a significant amount of memory and still saving every single undo state. Like I've worked for, days and days on single files. I just like go home, keep Fred running, and then come back. And then like I'll have an undo stack that's like super, super long. But I can still go back to any of them. And the memory usage is still very low. Like we can even look at what Fred's usage is right now. Let's look at processes. Right. It's using 7 megs, which is like the vast majority of that is OpenGL. Like that's just allocating the frame buffer.
Okay. Nice. Yeah. Nice.
So that's kind of the idea. And like you can keep branching, right? Like I can even branch all the way over here. Like what if I wanted to have this and then like, I don't know, exit failure, something like that. Now we have another branch over here. Right?
But you said like each of them is 2 pointers big, but like you still need to have textual representation of the diff, right? So you need to keep this as a string somewhere.
So the textual diff is actually generated by the Myers diff algorithm on demand. So when I say when I have this point that I'm at right here at the bottom, this point to this point, I take the text buffer snapshot that's right here, and I take the text buffer snapshot that's right here, and I literally run the Myers diff algorithm over it, and then I produce this diff output that you're seeing. So the combination of this is actually you're taking both of those snapshots and you're iterating the original buffer that was here and the original buffer that was here. So like when I have this minus is a view into this buffer here, and this plus is a view into this buffer here. And it's kind of mind-blowing when you think about it, but like it literally is just we're not storing any data, we're generating all this stuff on demand, and we're just taking those 2 pointers and saying like, show me the data structure snapshot that's here and show me the data structure snapshot that's here, and then like I'll just present it to you. I'll render it that way
Okay.
because it's still underlying the underlying data structure is still it's the same number of bytes. It's just like you're applying like a string view over it. You're taking a slice out of it and saving it somewhere.
Okay. Okay.
Yeah,
Nice.
I'm not sure if that makes a ton of sense, but
It
that's
makes like
kind of the idea.
the high level, and maybe if we will spend some time in the code, it might get clearer, right? But
Yeah.
nice. That's awesome. I like it so much.
Yeah, so that's the undo system, and it's very Git like, right? Like I mean, I can just keep going back to these things over and over again. And again, this has saved me from multiple angles. Like I've been in just this situation where I was like, I need that edit, so I'll go over here, take that out, right? I just copied that line by hitting YY, and then okay, I need to go back. I need to go back to hello Wookash. All right, let's insert that line. There it is.
Damn, that's so
Right.
smooth. I'm
Yeah.
I'm tracing like history of like what I need to do the same thing in like JetBrains ID or something, and it's like, oh, based on the Git history, I show the diff and see, okay, maybe this was the lines, like, and I can go switch to mouse, switch to this, switch to that. It's like,
Yeah, yeah, exactly. And being able to just have like that visual representation of the text is so powerful too. Um, I do eventually want to get to the point where I could do something like merge two nodes together. Like I have this node and I have this node. Like let's make a combination of those two nodes, right?
like,
Like that'd be
poof.
pretty sweet.
Nice.
Exactly. Exactly. Um, okay, but yeah, we can start diving into Fred if that
We
makes sense.
we can maybe do like a 5 to 10 minute break for people to ask questions if there are any,
Yeah.
and if you need to refill on water or anything, then we can do also like this, because like we've been going for an hour now, and
Yeah.
some minutes. So
I'm definitely ready for questions. I have my water right here, luckily.
nice. So are there any questions? Well, we have new member in the meantime joining the channel as a supporter. Thank you very much. I did not follow on chat because I was too blown away with the undo and the feature presentation. What is the undo algorithm called? I think you said a Mayer's diff for the diffing, right?
Yeah, so it uses the Myers-Diff algorithm. Right now, it's kind of like the inefficient one. I want to move to the linear space version. So if you don't know, Myers-Diff is kind of based on it's based on the Levenstein distance, and it just constructs this giant table, this like n by m table that traces a path to get to like the shortest distance, or like it finds the shortest distance to get the shortest number of edits to get from like A to B. And it's kind of like a snake that goes through this thing. But it requires a space complexity of n times m, right? So like if you have a buffer that's 100 lines big and you want to compare that to another buffer that's 100 lines big, it takes, 100 times 100 space complexity to represent that. There's another variant of the Myers-Diff algorithm which uses linear space, which is actually what I want to move to, and that's actually what Git uses as well. It uses that, or like sometimes it'll use this thing called the patience diff, which is a similar idea. But getting down to linear space will dramatically reduce the memory usage.
And as we know, we're like running very high on memory. Exactly. So
Yeah,
we have a lot of things to
exactly.
reduce.
Yeah, gotta optimize for the RAM nowadays. It's a hot commodity.
Somebody mentioned, does it work with Odin files? As
It does, actually, and it does. And I actually have an Odin file. Odin, or at least I thought I had an Odin. Hold on, I thought I had an Odin file. Wow, I thought I had an Odin file somewhere. But anyway, there's a tree sitter grammar for Odin, and I put that in because I know, like, handmade people really care about Odin, so it was important to me to support it. That's another reason why the plugin system's in C. It's really to kind of like inspire handmade people to maybe try it out because we really like C. C is like it's the foundational language. You have to support it.
There are people who are asking questions that have already been answered. This means that people were late, okay? It's like, I will take note. People who are asking, like, what about Helix editor? It's like, this is how we opened up the stream, man.
Yeah.
The Helix was so good that it prompted Cameron to do Fred, okay?
I had to do my own editor, my own Helix.
Does it come with support for three-sitter, or is it planned for the future?
Yes.
It comes with three-sitter. It's what being used for highlighting, syntax highlighting.
Yeah. And tree sitter will eventually be used to drive the go to definition as well.
Oh, really?
Yeah. Because most of the time you only need syntactic information for that stuff. So all you need to know is like, hey, where's like the function definition like node? And that you can navigate to that very easily.
But is tree-sitter able to tell per language what is a definition?
Yes. And that's actually an important aspect of tree sitter is like it has kind of this unified model to what the AST sort of looks like, and that's why the highlights are so like consistent across languages. So if let's see if I can actually find a different example. XML. Let's try and find like this thing, right? So this is XML highlighting, but I didn't change the highlighting schema from C to XML. It uses the same schema, but the tree nodes happen to line up in a way that like makes it look kind of like you're doing C-ish stuff. And so as long as you have like some amount of overlap of like, here's the concept of a definition of a thing, here's the concept of a type of a thing, that's all you would need. Now, you might have some special cases because like Odin has some interesting syntax in places that you might need to account for. Or like maybe you want to treat lambdas differently or something like that. But in general, it has like this very straightforward structure that's like kind of unified in a lot of ways.
Got it. There's lots of questions. Oh, will virtual white space be supported? I feel Alan energy now.
Yeah, so I want to support virtual whitespace because that is a feature of 4Coder that I absolutely love. Virtual whitespace, if you don't already know, is kind of like this approach, or it's this way of kind of like rendering text that doesn't rely on like what the backing text buffer is, but still aligns like declarations and types and stuff like that in a way that's very intuitive to kind of look at. So it eliminates this idea of like, are we using tabs or spaces? It kind of doesn't matter when you have virtual whitespace. You're just kind of aligning everything the way that is natural for you to look at. And then like people can have their tabs, people can have their spaces, and it just doesn't matter. Eventually I want to get to a place where Fred can do that as well. But all it does right now is it kind of gives you like the snapshot of the buffer. It does some special things here and there, but in general, it's like very, the text rendering is like very straightforward, but I'm intentionally keeping it simple for now because one, I want to keep it fast, and two, I want to make sure that I really nail down like the representation of the text buffer itself before I start venturing into, okay, now how can we apply more rendering stuff on top of that?
Oh, somebody mentioned that during your find all showcase, they searched for type def inside /user/include. And it took less than 1 second on the entire Linux distribution, like /user/include, search for a word,
nice.
type def.
Yeah, that's the whole thing. It's like if if you know this is actually one piece that I don't know, maybe I'll get some flack for, but I really appreciate the idea that I really appreciate that I had a computer science degree because it helps you pattern match algorithms to problems. And like I think that's the most useful piece of having a computer science degree, which is that like you're able to see a problem and then like conceptually like some algorithm exists to solve this problem in a very specific way. And in this case, like text searching, it's a pretty solved problem if you kind of like have some constraints around it. And so that's basically the approach I took for my text search. Like, okay, I have these constraints. I can do this extremely quickly if I have like this data structure and I apply this algorithm. That's the idea.
Nice. Then let's go and see some code.
Yeah. Okay. So maybe we can start with like just the main entry point so you can kind of see like how I set up a whole bunch of crap. and then maybe we can dig into specific architectural pieces. So like if we're looking at the architecture, this is kind of how things are broken up again. The main would actually fall kind of closer to something like Fred core because it's setting up very Fred specific stuff. Here I only have header files because most of the time header file corresponds directly to a CPP file. There's very few cases where I have a CPP file and no header file for it. There's actually only 3 cases. One of them is main, and the other 2 are the platform-specific OS CPP files. So there's one for Linux, and then there's one for Win32. Okay.
But given that's Unity build, you shouldn't have many CPP files anyway, right? Like
yeah.
You have.
Well, I separate them out just for just to have them be like a little bit more self-contained. For example, like find all. I kind of want all that code to be grouped in one file so I can kind of search for it. But with a Unity build, yeah, like you said, it kind of just doesn't matter that they're separated into files. It's just more for convenience and like searching purposes and stuff like that. Okay, so let's take a look at main.cpp. So this is my main. This thing is 3,241 lines long. And yeah, like I said, it just Unity builds all this stuff together. And this is one thing, okay, this is a little pet peeve of mine just because I'm a compiler writer. I am always shocked at the number of people who write their Unity files and they put the CPPs at the very top. And like, I kind of get maybe why you might do that if you don't have header files. But some people have header files and they have CPP files. And then I'm just shocked at like, why do you put all this stuff at the top? Because what happens is, once you get down to the platform specific stuff, like Win32 and Linux in particular, these files massively poison everything else beneath it. So when you hash include like your platform layer for Linux, it's going to define stuff that might like clash and overlap and mess up all kinds of stuff. One thing I ran into was glyph. So this thing here, right? Like this is kind of a hack to make glyph work. Xrandr, when you include that thing, defines its own glyph like name, and it defines it as like, it's a type def. But I already have glyph as a namespace in my program, so it like totally messes everything up. Anyway, that's a pet peeve of mine. People can still do what they want, but I massively prefer having all the CPPs at the very, very end. Yeah, hash including those at the very end. It's also faster for compiler throughput, by the way, because
really,
when you get to template instantiations are typically done at the end of like certain functions and stuff like that. And so if you sequence it in a way where your function definitions kind of come last, sometimes you can get some compiler throughput that way. It's a weird little trick you can do if you like know the compiler you're working with. So in my case,
you want templates before functions.
You want certain template instantiations to happen earlier than others. And so like the ordering of those template instantiations can matter a lot. And so when you have the definitions happen after all of the like hash includes above, oftentimes you can get a little bit of throughput through like context-spur and various things like this if you have these down here. I don't know. It's a weird thing. I just noticed it when I moved.
You just know too much, at this point. You know too much of what will happen.
Yeah,
and you're
exactly.
Like, oof, this order. Damn.
Yep. It's like the cursed with knowledge thing, right? Like Tony Stark. Yeah.
Exactly.
Okay, so if we do Fred Fred main, this is the main entry that you will see with any of my handmade projects. Well, I mean, sometimes it won't be called Fred main, but the platform layer calls out to this function, which is like it sets up its own platform specific main, and then it like it goes into this thing. So eventually, like what you want to do is like you set up your primary arena for anything that belongs like for the entire program space. So it's like my main entry arena. This thing holds stuff like certain widgets. It'll hold stuff or like widgets that need to live all the way to the end of the program. An example of that is like the find widget. Because I only have one of them, I just stick it in this arena and call it a day. Find all is a different one. That's a dynamic widget. I know, it's really weird. And then you have your config. So the config is another thing that I start very, very early because you want to be able to, if you have layout that's specific to like resizing the window or like putting serializing editors that you like last closed Fred with, you want to have this happen first, and then you can start, munging through all the configuration data immediately after this. And it doesn't depend on anything else, right? Like it's literally parsing a TOML file. And so the only thing you need is a arena.
And arena, for people who don't know, is a way to manage memory and pretty much put things in like a large allocated block and not to worry too much about like, oh, we need to do this separately because it's C++. I need to have a new and then distractor so that we can deallocate the memory. It's just like you reserve a huge chunk of memory, and then when you need to create an object, you have this memory separated, and you're like, hey, give me those 3 bytes here.
Yeah, exactly. Think of it as like a giant array that you have an index into, and you can like bump that index forward or backward, and like you have this like kind of fixed size region that you can play with. But you can't go past that, or maybe you can in some cases. But like, the idea is like you have this kind of array that's already allocated for you, and that's the whole idea. And by the way, here I'll show you kind of like a snapshot of the arena, arena.h. So this is my arena header, and this drives every memory allocation in Fred. It took me a while to get onto the arena bandwagon for Fred, unfortunately. Like I only just started it, at the beginning of last year. And then I converted literally everything to use arenas. Well, there's still some things that aren't arena-ized. I just haven't prioritized them, and I haven't had time. But the vast majority of everything is all arenas. And I get out of the C++ nonsense by ensuring that anything I allocate into an arena doesn't have C++, semantics behind it. For example, non-trivial destructors. Non-trivial destructors, for those who don't know, is something like when you allocate a vector, or when you declare a vector on the stack, when you exit that scope, the vector destructor runs, and then it like cleans up its memory. And that destructor itself is called a non-trivial destructor, and it executes some code that you don't really have control of. I want to get rid of all that stuff because I want control over what happens after an object goes out of scope. Or I basically want nothing to happen at all, essentially. So in our arena allocator, we have this. Like this is an assertion that must be met for any arena allocation. You cannot have a non-trivial destructor. So like no C++ objects can pass through my arenas at all.
Wow.
And that's been a really big help in dramatically simplifying object lifetimes in the editor itself. And you'll notice I don't have any memory leaks or anything like that. Yeah, I've never had a memory issue with allocators so far.
That's so, that's so funny. Like so many C++ features are like trying to fix and help you. And then like the ideal fix, the perfect fix is just to not use them.
Exactly, exactly. And actually, here, let me kind of build this with so there's this option I have called Track Arena, which is an optional widget that I can build into Fred, and I'll just show you what it does. So, okay, I just loaded this thing. Let's go ahead and let me open up this stuff. Um, I don't need this anymore. So I have this Track Arena thing, which is just for me. I don't ship this, but it lets me see like the status of all the arenas
Ooh.
and like their peak sizes and stuff, and like I can kind of sort this. I can sort it on commit. By the way, if you use arenas in your project, make sure you keep track of how much you have committed, because that can turn into a memory leak. So it's very important for me to like make sure that I keep track of commits. But you can sort it by size. Like these are every single arena that I have allocated for Fred. Here's like the peak size that arena was. Like, oh, at some point I reserved 1.2 megabytes for File Explorer. And you can actually see where that happened. Like if I click this, it takes me to the line.
Damn.
It takes me to the line where it was. So I have this like really elaborate tracking mechanism set up for all my arenas, because I am obsessed with making sure that Fred is very memory efficient and is very fast on top of that. So this is a very good thing for anybody trying to use arenas. Try and set up something like this. Yeah.
Nice.
And that's all driven from arena.h. Like I have this so there's this track arena macro that only inserts extra stuff if you have it activated. So normally arenas are a lot cheaper, but if you have that, then you can take like these snapshots, and like that's what populates the arena tracker thing, right?
I like you open up and you show like here are like UI components. Here's Fred core, here's core, and this is project. No, I didn't do projects. I was like, okay, like so I get this idea of being like a raw Vim editor kind of, don't have projects, like maybe some functionality is missing or something, and it's like here's find all, it scans through like blazingly fast, and here's like arena reports like tracking how much, and if I click I go exactly, it's like, bro, you have more integrations for this like raw editor than like most IDEs that have tons of features but people don't use them, and they're just there sitting, like Docker integration, which is like, okay, and you have like pinpoint, like, oh, I wanted this arena, it's a boom.
Well, like a lot of it is really because I am pedantic, and that I'm very paranoid of shipping something that's like really low quality, and so I basically never ship anything unless it's absolutely amazing, or at least for my definition of what amazing is. So I make sure that everything is like super polished by the time I get it out to people, and that there's like no crashes or anything like that. I very, very rarely have crashes that happen in the editor. And if they do happen, it's just because like I did something very obviously dumb, right? But most of the time, it's intended to be an extremely stable experience. And then so moving to arenas from like the C++ allocator and all that nonsense, it actually improved how frequently, or like let me step back. It helped me have fewer crashes because I could rationalize what lifetimes are of pointers that I had around the editor. And I'm also very paranoid about pointers as well. So like if I pass a pointer into a function, that pointer is never null. I do not use null pointer as an optional parameter to any function ever. Like that is a very hardcore thing that I'm adamant about.
Are you like throwing asserts everywhere? on every function, or?
It's I could throw asserts, but it's just the way that when I write code, I just don't do that. I depend on a like it if I need something that needs to be it has an optional parameter, I don't use no pointer. Instead, I use a flag, and I still pass like a dummy object or something into it.
Okay.
Yeah. It's more of like a coding convention than it is like, oh, there's tooling to make sure that this happens. And I also run it through ASAN and stuff like that too. Like ASAN is another thing that you have to build into your app right away. So like in here, I have actually I have to go. So if I have ASAN active, you have these things that are super helpful to have with arenas. So like making sure that you properly poison your memory regions when you release them, or like making sure that you unpoison them when you make them available. That these are extremely useful things to have whenever you're building up your own arenas.
Wait, I thought
because they make ASAN possible.
ASAN meaning address sanitizers.
Yes, address sanitizer.
Shouldn't be. Can you say it again, or describe how should this work with poisoning and unpoisoning memory regions?
So basically, here we can go to push internal. This is a good example. Whenever you create space in your arena, what you want to do is you want to bump that allocation forward, and then you want to tell address sanitizer like, hey, this region of memory is now accessible for the application. So I want you to inform like the shadow memory piece of it to say like, hey, you don't need to do checks on this anymore. So like we're going to unpoison that, and now people can, or now the rest of the application can use this block. So that's what unpoison region does for you. And what poison region does for you is it does exactly the opposite. So when you release a section of memory, let's see, right. When you do pop2, which is like I want to move the memory pointer back, like I don't care about this memory anymore, you make sure that you poison that memory region. So if you have, say, a pointer to an object that's still sitting in there, and you try to access it later, ASAN will trip up a like an error and say like, hey, you tried to access a pointer that's in poison memory, and like here's where it happened, and like, oh, that was dumb. I shouldn't have done that. Yeah. So that's the whole idea.
Okay.
Making sure that your memory arenas are ASAN aware.
For a second, I thought you say that we're going to poison the memory that we're going to use. And I was like, what? Wasn't this the other way? No. But okay, it's actually the other way. We poison when you release it, and you unpoison when you want to use it again. That's fine.
Yeah, precisely. Sorry, I think maybe I messed up right there. Okay. So yeah, that's all the stuff, and then obviously some arena tracker logic in here. Okay, so we can go back to our main function.
Yes, this was arena detour.
Yeah, the arena detour, and we can keep taking detours, or we can go deep. But maybe it actually is kind of helpful to see like, oh, what does this arena thing mean, right? As we're walking through this stuff. So the message feed is like this very simple thing. So when you saw those messages at the bottom here, that was coming from this thing. And it's just a very simple, like it keeps like an arena of like strings that are displayed to the user for a certain amount of time, then they fade away. So for example, like if I show, here's another Fred flex right here, right? Like we're running at 240 FPS and the only limitation there is the fact that I'm VSync. So like if I turn off VSync, it'll probably be, hundreds more FPS. But make sure that you're looking at your FPS. And again, this is debug code.
to appreciate all the smooth animations of cursor and
yeah, that's all driven by like some shader magic and some like offset magic too. Like when you open up Windows and stuff like that, that's all driven by offset fun stuff that I learned from Ryan Fleary, by the way, who is a god when it comes to figuring out like how UIs work. And so I just basically stole a whole bunch of his ideas from his UI tutorial.
It felt like kind of RAD debugger cursor style jumping around.
Yeah. Yeah, definitely took it from him. When I saw the original Dion project, he had a cursor that was a lot like this. I'm like, that needs to be in Fred right now. I must have that. And then it's funny too, because like not too long after I finished my cursor that did this, he actually did one for Rad Debugger too. So
Okay.
it's kind of a fun little cross pollination thing, maybe. But yeah, so this message feed, whenever I turn on stuff, you can see like it populates in here. And it takes care of its own allocation. So for example, once they're all faded away, and it knows it doesn't need to render anything, it'll kind of clear that arena and make space for new messages and stuff like that. So it's kind of like a self-reaping system. So the config file, right? This is if you have a config file. If you don't have a config file, Fred will try to create one on your behalf. So the first time Fred experience, when you load up the editor, it's going to say like, oh, you don't have a config file. I'm going to create one for you. Oh, you don't have a hotkeys file. I'm going to create one for you. And so it will create this thing, and it'll create like this hotkeys.toml. Which are really just, it's a description of any of the hotkeys that are available in this thing, right? And these are all rebindable, by the way. You can rebind them to literally anything. So if I do like, let's rebind this to F1, right? It even tells you that there's a conflict here. And, oh, let's show the conflicts. Oh, okay, these conflict with this one, and that conflicts with this one. All right, let's revert that, and now we don't have any conflicts, right? But anyway, the hotkey file is what drives this thing here. And so if I actually, maybe you can even see it update. If I have show help here, I change it to F2. See, now it changed. That's another thing Fred does, is it like monitors the file that you have open. So if you update it, it will update in real time. So if I go say reset to default, it should reset. There it is.
Nice.
Anyway, yeah, very useful feature. But anyway, so that's what this config stuff does. And then finally we have our init loading, or like our OS loading. So this reaches into the OS layer and says, hey, make me a window that's capable of rendering stuff. And then I'm going to go ahead and initialize my platform renderer, which is right now, it's unfortunately only an OpenGL renderer. But I'm working really hard to create a DXD11. A D3D11 renderer, because I have to have a software renderer. And it's a very sad story, but the reason I have to have that is because at work we have these like dev box things, and they don't support graphics cards. They only support software rendered apps. And of course, OpenGL just explodes when you try to render it through, VNC. And so VNC is the reason why it's like actually a pretty strong motivator for me to get some kind of software rendering mechanism into Fred. So I'm working on that in the background. Anyway, yeah, platform render. There's some like debug stuff here. And then finally we get into the command list and the draw list allocators. So this is kind of dropping into This is dropping into the UI portion where we have the command buffer for rendering. So Fred is all driven off of this command buffer idea, which if you're familiar with like IM GUI or Ryan style or Alan style kind of rendering, you have this giant list of render commands that you issue to the GPU at some point. And it just contains like a list of vertices and like the style and the fragment shader and the vertex shader that you're using. So we batch those up as much as we possibly can, submit them to the GPU, and then poof, like that's how you get your render. That's how you get like your screen. You just present this thing, and then you clear it at the end of the frame, and then you come back to the next frame, and then you start adding more stuff to it. So that's what this command list thing is for. And there's only one of these things. So the command list has a list of draw lists. It's kind of confusing, but it has this list of draw lists that it draws in order. So like if you put a draw list in front of another, that will render on top of everything, because you render like back to front. So yeah, that's kind of the idea. And you can kind of see that. Oops, let's go back. So so the command API kind of has this stuff where you can draw like a whole bunch of, you can query some things, you can push some textures, right? Like if you need a specific kind of texture, you can push it to the command list or the draw list.
But you build those.
And
You build those from scratch, right? Every frame.
yes,
Yeah. Okay.
all from scratch, every single frame. But because it's an arena, it's like literally moving a pointer. So it's extremely cheap to do.
Because you persist this in Arena, but it's built again. Okay. Because it's immediate mode.
Yeah.
Okay.
Exactly. And here's the like super awesome thing about arena. Like this is just another amazing thing about arenas and what you can do with operating systems that support virtual memory is that you can reserve like megabytes or even gigabytes of memory, and you can create an array that just sits at the beginning of that arena and have it continuously grow all the way out to the end of that arena. But you don't have to commit that memory if you don't want to. Like your working set will only be as big as like you need for that specific array. And so like if you just need it to grow larger, the OS will like commit more, or the system will just commit more pages for you, and like boom, you still have an array that's got the same address, but now you can add more elements to it. Like it's just so nice, right? And that's the whole thing that drives this draw list. Because when you submit it to the GPU, you really want that to be in array form. So like you literally just take that chunk of memory and do a mem copy, and boom, right? Like that's all you need for vertices. It's great.
That's when I learned about like arenas and sort of low level tactics. It's so sad that not many frameworks that are very popular today have bought into this, you know, like because if you're using Qt, for example, which is like a dominant C++ solution, you don't get to enjoy arenas. You can enjoy them on your hobby projects, you know, like you need to have them baked in sort of from the start, or have your epiphany moment where you go like, no, we want to use arenas, and then like you scratch the entire like memory style allocation you've done so far, and then now replace it with arenas. But you need to have a control over entire project, and you here are low level enough. You have your own renderer, you can do that.
Yeah,
it's tricky. It's quite sad that there is no like production, super popular in production framework that would support these, and you need to have them in your kind of.
yeah, exactly. And like most libraries that want to try and use custom allocators try to specialize through like crazy amount of C++ template goop. Like it's crazy to try and like compile these things because they're so dang complex. They want to hit every edge case, but like realistically, you don't need to solve the vast majority of the problems that kind of thing is meant to solve. Like you just want, all you really need at the end of the day is like a region of memory that you can submit to the GPU. And like it's not hard to write that kind of stuff, right? Like you can look, I can show you so in the CPP arena push, right? Like this is all the code that it takes to extend that array, right? Like we look and see how much we have, or how much we have reserved, or we look at what the base pointer is right now, and then we take that and bump it by whatever X is. And like this is the whole thing that does that. And then there's like an assertion to make sure that we don't go past, or that we still have the same base pointer. And then we just bump the count. Like there's nothing to that. Whereas like you in a larger application, you do like vector pushback, and God knows how much code you're going to go through to make sure that pushback actually works, right? Like it has to do a resize check, yes. And then it's got to like, maybe it's going to reallocate some more memory and like blit it to that memory and then throw away the old piece, right? You don't need to do that with arrays or with arenas. You literally are just bumping a pointer. It's so fast.
How come you have an or there? Is this Python?
Okay, that's another thing that's probably I'm gonna catch some flack though. In C++, it natively supports this like alternative spelling for the logical operators, like
What?
and or, right? That kind of stuff. I very much greatly prefer those over just having like the knots, because sometimes it's like it's hard for me to kind of read where it's like, oh, it's like this or that, whereas, and especially like not, oops, assuming I can spell it right. So not, right, not is actually a really good case for having this, because if you have this, um it's kind of easy to hide, it's kind of easy to overlook the fact that this was not, right? You could be like, oh, okay, it's this box is outside the clip if the UA if the UI, has this ABB box and like PB is inside there. But except that this function is testing if we're outside the clip. So you actually want to invert that thing. And it's kind of easy to overlook the fact that this has a little knot in front of it, at least for me. Whereas if I have this, it's much more obvious. Like there's even a space there. Like I'm not going to miss that.
This is MSVC only, or is it all compilers?
No, this is the standard C++ thing.
Okay. Wow.
Yeah, ever since C++ 98, it has supported this thing.
Okay.
Except that in the Microsoft compiler, you have to enable permissive minus, or you have to enable permissive minus to do this.
Okay.
Otherwise, it won't work, right? Like the Microsoft compiler is so old that it doesn't want to break. It doesn't want to break old code, so you have to opt into the like named the alternative spelling of these things.
Wow. Somebody in the chat, Aretan, asked, "Can we turn off the cursor animation?" Wow.
Yes,
such a hurtful, painful question. Like we just talked about like how cool the animation is, and then you're like, "Can we turn off?"
But sometimes you might not want it, and like maybe it's distracting to some people. So like, enable cursor animations. Like you can just turn that off, right? And so now I can have like my cursor, and it just appears, right?
What's embolden? What's embolden?
Embolden. So embolden cursor. Normally, when you have just the regular Vim cursor, it's got this kind of bold look to it, right?
Yeah.
However, when you go to insert mode, you get the little cursor, right?
Yeah.
But embolden lets the insert mode cursor be big as well. So now it's like,
oh, that's nasty.
Like a large, yeah.
That's nasty.
Well, somebody requested it, and I was like, I could do that. It's basically free, right? I don't know if I necessarily like it, but some people won't like it. Just as some people like disabling cursor animations. I kind of like having the animations. I think it's a little bit more fun. And sometimes it's actually kind of useful to see like where your cursor comes from, because sometimes I'll get lost. I'll be like, all right, where's my cursor? Oh, I came back from there. All right, so now I can go back and forth between there pretty easily, right? That's another feature of Fred, by the way. Is like you can go, you have this thing like previous cursor position or like future cursor position, where you hold Alt left or right and it goes like back or forward. So like you can trace through where your cursor has been since opening this file, right? It's a useful feature. It's like a really nice little navigation thing.
Nice. But again, I interrupted because I've seen or and then not, and then we talked about cursor animations, and this was all a discussion from the command buffer, right? And the draw lists.
Yeah. So from the control or the command buffer. So yeah, there was a slight little detour. Right, we have the init draw list alloc. This is just a big arena that like you could dump all the command or all of the draw lists into, and the draw lists have their own arenas that allocate those big arrays that I was talking about.
Got it.
Okay, and so now we have this. This is one thing I've been needing to get rid of for a very long time. The scene renderer thing. This is like this is an old concept that I actually brought over from a game or like game programming that I had done previously, where I had this concept of a scene renderer where you can like go from a pause menu to like the game menu, and then like you go to like the next scene and the next scene. You just don't need that for Fred. Like it just kind of is really redundant. So the only thing the renderer serves as a thing in the editor anymore is like it's the way to do stuff like special effects. And let me show you that kind of stuff. CRT. So there's this CRT effect, which is all driven by shaders. So when you enable that, it like kind of turns it into like you got this vignette going on, right? You get some like kind of crazy. If you zoom in a little bit, you can see like there's literally pixels there, right? And so it's like rendering all that. So you could turn off the vignette. CRT. So you can turn off screen. You can enable the screen warp, or you can turn it off, right? So if you want it to be flat,
but
you can just do that.
Flat,
so
now
but it's
CRT.
just like
Nice.
flat but CRT mode, right? And it's just a shader that I'm applying to everything. So like I render everything to a frame buffer because like that's how you get blurring effects and stuff like that. So because I have everything in a frame buffer, I can just take that frame buffer and start blitting it all over the place and make like a CRT effect like this. Screen warp. So let's turn that back on. But then CRT effect, you can just turn it on.
So you're basically free to do all sorts of post-processing effects from games now because you already have it set up in frame buffer. So you'll be like, if you have this like distortion, like the chroma aberration, when you know, like it's a popular effect now in games where you have the red channel and blue channel kind of slip up to different. Like you can do this as well on the keystroke. So it's like every time you type.
Yeah.
Perfect.
Yeah, I kind of did that like with the. You can kind of see like that sort of effect happening there. But yeah, I would love to be able to do that kind of thing. And eventually that's the kind of thing I want to expose through the plugin system too. Like it would be so cool if you could literally author a little fragment shader that applied to like a frame buffer or something like that. Like what if you wanted to run your own logic through that? And that's totally something you can do because not only is the plugin system hot reloadable because it's all TCC based, but the shader system is hot reloadable. So you can F6, you can see reloading shaders, right? Like it literally reads in the shaders that are right now they're embedded in Fred, reloads the shaders, runs them through OpenGL, and like applies them again.
Nice.
So it's got hot reloading all over the place, which is cool.
Nice.
I actually probably should take that feature out for now because it kind of doesn't do anything since I don't ship the shaders anymore. But that's the concept. You can you should be able to do something like that.
I'm looking at the more things. I think we can go through the main, and then we can pick like one or two systems and go a little bit more in depth. I'm interested in terms of like how generally speaking you deal with multi-threading. Like is it can see the thread pool, but is it like, you know, there are certain threads that do their own respective things, and then if you need like find all, then you have like you spawn a new thing, or is it like you common thread pool that you reuse for all the sorts of things, like this kind of situations?
Yeah. We can actually, since the thread pool is literally right here, we can just talk about that right now.
Nice.
So the thread pool, it is a pool that's shared with the entire application. And that's kind of by design because I don't want a lot of context switching happening. And to be honest, you're not doing that much. You're not doing too much stuff, you know, with threads all of the time in the editor. Mostly it's just for like, you know, incremental search, and then like find all, and then the actual syntax highlighting when I go to parse the text file with Tree Sitter, that's done on a thread. And then stuff like figuring out the line guides. So you see like these kind of like lines here. Those are all computed on a background thread. It's computed with this information that I call additional buffer information. So it tells you like the indentation information and like a whole bunch of other stuff.
When is it computed, then it needs to be somewhat communicated to the main thread for UI, right?
Yes, exactly.
How does this happen?
And so that's where a thread comes into place. So thread is kind of broken down into this idea that I have like specific requests I want to make to the thread pool, and it submits it to this queue. Like it's just a concurrent queue that has like a single mutex around it, where the threads are looking at this queue, and then if there's nothing there, they kind of go back to sleep. And that's kind of their entire loop. It's extremely simple, but it's very effective actually at making threads available when you need them to be available. So we have like these individual requests that are kind of broken down. So like there's search results, there's chunked search results. This chunked search results thing is actually the incremental search. And this search results thing is a single search that's done over the entire buffer. That's for stuff like, have you noticed when I move the cursor over a word, it like highlights another word? That happens on a background thread. So when the cursor moves over, it like extracts the word and tells the thread pool, hey, I want to look for any word that looks like this in the buffer, and submits that to the thread pool, and then you get that back as like this thing. And then chunk search results are happening basically on the foreground thread. And I can show you the like function that does this because it's kind of interesting. But then you have this like extra buffer. It's just like all these different requests, right? So you submit a request using one of these functions here, background task. It's kind of messy right now. Like I want to eventually move it to like a mega struct idea, like what Ryan Fleary has. This way it's like one background task, and then boom, you just do anything you want. And then you have result if complete. And so it accepts this handle thing and asks the results queue if there's anything that matches that handle. So there's this input queue and there's a separate results queue. And they're locked independently of each other. This way threads don't have like contention for one or the other. And so when we get these results back, then we obviously have like, we get that pointer back, and now we basically own that memory. So it's allocated in a tiny little arena for us. You get that memory back, and then whatever widget wanted to use the result can like use it or throw it away or do whatever they want with it. And then we have ways of canceling tasks. And these are all driven by atomics. So every block of thread work has an atomic variable that says like, hey, am I being canceled? Am I not being canceled? And you can check that on a case by case basis, like depending on how long the work is, and say like, oh, okay, I want to cancel this now, and I'll just stop it. For example, find all. When you do find all is a long enough task to where if you want to cancel it, you probably should make sure that thread is looking for that variable and like cancels it on time, right? So that's one thing that's one place where cancel task actually makes a lot more sense. But I just attach it to everything kind of by itself. But if we look at thread.cpp, so the major work of thread.cpp happens in here, and these threads kind of do double duty. So there's the main requests that come in, and then there's these things that I call async requests. And those are fit for stuff like file tracking. So the file tracker has this specific thing that does like async map tick, where it checks to see if the file has changed on disk, and it does that on a background thread. And sometimes it'll do this, and sometimes it won't do this. So it kind of just depends on whenever a thread gets woken up and checks this variable and sees like, oh, okay, I need to execute this task. Let's go ahead and see if any files have changed on disk. So they do the main queue, or they do this. But then everything else is like pretty straightforward. Like we unlock our mutex, and then we go into the thread work, which is like, these are functions that are kind of distributed around the code base. But eventually, like I said, this needs to be closer to what something like Ryan has, where either you have this like lane idea where like all the threads are kind of intermixed in the main thread, or you do something like you submit bulk work to this thing, and like it can be anything. So we don't have all these extra types floating around, because the types are just, it's just really work that is kind of unnecessary.
Just the stuff that you need to type to add a new one, but on the like the actual execution level, it doesn't really matter that much, right? Like to add a new type.
Yeah, exactly. It's literally just more typing for me that kind of doesn't serve much of a purpose anymore. When I first designed this, it served a little bit more of a purpose because it was more like based on unique pointers and like it had shared pointers all over the place and it was terrible. But now that it's like kind of arena based and everything's like kind of homogeneously allocated, because I have these like entry things that contain everything, it makes way more sense to just have a single thing to hold all of this stuff and to make requests. So that's eventually what I want to move to.
I like that we already got in like one sentence the smart pointers summary, you know.
Yeah. Smart pointers they're fine until you break them and then they never work, right? Like that's basically how it breaks down. Just to give you an example, chunk search result. So chunked search result, thread chunks. By the way, this is ed.cpp. So like this is the main editor that you see all over the place. This guy is 12,000 lines long. You know, it's a pretty short file.
Okay. What do you mean?
I kind of like it.
What do you mean you see everywhere? Like in what way we see?
So this is the file that drives everything editor related. All of the cursor movement, all of the buffer interaction, anything that happens to like modify has to do with modifying or viewing a buffer. It's all inside here. That's kind of why the file is so big. But honestly, like I'm fine with big files. 12,000 lines file, not a problem. Right? Like at work, I work on files that are hundreds of thousands of lines long. So this is nothing compared to what I usually work with. And Fred handles it just fine, right? Like you have no problems editing anything, right? Totally fine.
Nice.
So this is just to give you a quick example of like how I break up the search results. So the search results happen, it's kind of heuristic. So if the file is small enough, I'll just search for it on like the main thread. However, if the line count is like larger than this search threshold thing, which is 100 lines, then we go down into the chunked piece. And like that's where things get a little bit more interesting. And I basically split up the lines into chunks, and then I take a snapshot of the current buffer and I give it to all of those threads. Because the cool thing about FredBuff, because it's a pure functional data structure, is it's inherently thread safe. Like you can't break it like by giving a thread like a snapshot of this thing and then making a change somewhere else. It just doesn't work that way. So you can take a snapshot of any thread buff and it will be valid for whatever you want to use it for, no matter what happens.
When you say take a snapshot, do you mean copy?
Yeah, copy. And again, that copy is basically like a pointer, right? It's literally a pointer, which is great. So, so when I take that snapshot, I give it to all the thread chunks. I split them up per chunk, and then I also have the main UI thread participate in the search, because like it's a thread that could be doing work, right? Like why not make it do something? And so the main thread on the results on the core thread, the main thread does a little bit more of the searching than all of the threads do, because the threads, you still have to distribute the work and then you have to put it in a results queue. So I just make the main thread do like probably twice as much work as everything else. And then you collect them all up, right? The way that these results work is that we have a condition variable on each of the threads that is activated whenever that thread finishes its search. And so this is important because what we want to do is we want to like go wide. We want to have like all the threads search for their terms, and then we want to come back to the main thread immediately. we don't want to go to the next frame and present that result later. We actually just want to do it all in one single frame. And so like that's why this wait condition is here. But realistically, you never hit cases where the thread takes that, or like the search takes that long, unless you have like one thread or something. But even then, it's like not that bad. And then you like join up all the results, right? It's just a whole bunch of insertions that happen.
You made it sound you make it sound so easy, you know. It's like, how do you search? Like, well, if the file is long enough, you split it, and then you use all your threads to search, and then you merge it. What's the problem?
Yeah,
here's the score.
There's no problem.
80 milliseconds on 600,000 lines of file.
Yeah, it's super easy. I don't know why you can't do it. Anybody could do this. Like, I mean, really. I'm not even that smart, to be honest. I just have a lot of determination when it comes to solving a problem, and it's really just me like banging my head against the wall and making things work. Like that's really all my programming comes down to do. Somebody far more competent than me, like I don't know, Ryan or Alan, could probably do this in less than an hour or so. But this took me about a day to figure out like how to do.
What about you have this, for example, thread functions, and then you had OS functions. At some level, you need an implementation. I'm sort of guessing that you don't use a lot of STD, so you have your own implementations for the platform functions.
I do. So for the platform function, and we can look at this too. Let's just look at our os.h. There's like a whole bunch of
whoa.
There's a whole bunch of atomic operations up here that are defined as macros. And I do that because I don't like to go through another function whenever I'm operating at an atomic level. I want it to happen like as soon as humanly possible. So that's why these are all macros. But here's like our OS layer, right? We have a whole bunch of we can get events from our OS layer. We have ticks and stuff like that. And then come all the fun API. There's a whole bunch of type defs. But here's all our fun, APIs, right? Like we have everything that's for windowing, for error info. These are event processing. And everything, of course, is arena-fied.
Of course.
Clipboard text, which...
Of course.
Yeah, clipboard text, which is obnoxious in X11. If you've ever done clipboard text extraction in X11, it's just horrendously bad.
Okay.
I don't know who thought that was a good idea. And then there's clipboard HTML, which is actually kind of a Windows specific thing. So like you can attach like this MIME data to your clipboard text. And so if I copy some text like this and I paste it into something that knows how to interpret HTML, it can sort of like, I'll present it as HTML instead of normal text, right? Okay. Like that's kind of a cool little function of a thread that you can have.
You mean like I have an HTML file open and I copy a chunk of it, and then when I paste it, it will be interpreted HTML. So if there was like a link, it will be a link.
Yeah. So let me show you kind of an example of what this might look like. If I do, can I break this into a window? Can I do something like compose and then let me see if we can maybe, hopefully this won't, okay. I don't think this is showing any sensitive data, which is fine. Okay, so say I have this window for composing a Gmail, for example, because Gmail is like one of these places where it can actually interpret this stuff. If I copy like this stuff, so I Control-C, and this only works on Windows. Again, I don't know how to get it to work on Linux. But if I Control-C it, you can see that it actually pastes as like styled text. Okay. But it works better actually if I have it in light mode. Hopefully I'm not going to flashbang everybody. Okay. Get ready. Okay. It works much better from this. And I Control V, right? Like, look at that. It looks so much better than if I just pasted regular text. It like actually has the color it has the color codes that I'm using in Thread encoded in HTML.
Okay, that's
Yeah.
that's a surprising feature. I mean, for a code editor, because I think I've seen this, like if you between docs and like you sometimes keep the styling if you copy something, but I wouldn't think about it in a text editor.
Yeah, it works. It's really cool because I use this all the time for showing code. Let me turn off flight mode.
Enough.
I use this all the time for showing off code to colleagues. And it's just helpful to have the syntax there because it's like it helps guide readers into the thing that actually matters, right? Especially when you're talking to a whole bunch of compiler engineers. Like we think very much in terms of syntax. And so that's a very good feature for me to have personally, which is why I have it.
Nice.
So going back to the thread idea, here's like directory stuff. So thread handling, those are for processes. Okay, threading. So launch thread, join thread, thread entry bridge, all this stuff. This is all stuff that's designed to launch threads from whatever the OS API is. So in win32.cpp, so if I go to launch thread, right, we have win32 alloc thread, which is a special function that just dispatches out to create thread and does all of its like, pass your 20 parameters to the Win API or whatever, and there you go. And so like that's how all this stuff ends up working. Same thing for like joining thread, right? Wait for single object, all that fun stuff.
Okay. So and for Arena, of course, you have your implementations. OS level, you have your implementations, and depending on the OS, of course, for data structures, like you mentioned array, I'm assuming you have like Arena-backed arrays, as you mentioned, and so you don't really use like vectors and maps and from standard library.
Yeah, well, I don't use std_map, but I have my own hash table that I kind of like custom write, right? Like, so if I go to glyph cache, glyph cache is the thing that's responsible for, creating the atlas. Yeah, it's responsible for creating the atlas. So here's like the atlas that I have. The reason it's all spread out like that is because I'm rendering subpixel font, so you have to have like the wider glyphs to have subpixel font rendering. But anyway, this thing has a map behind it because you want to be able to map code points to specific glyphs, right? In the case where you're outside of ASCII, you want to be able to very quickly access what the glyph is for a specific code point, and that's what this glyph code point key thing is, and this Unicode glyph map. And the great thing about Unicode, at least UTF-32, is that all your code points are already unique. So you don't actually even have to hash what the code point is. You just literally access it from the array. So this is the thing that I end up using for that. So, right, we have like, certain number of buckets, we have like a size or a capacity for this thing, and then we just allocate slots for it. It's just a separately chained hash table. It's not like linear probing. I could use linear probing, but it's kind of unnecessary when you have like such a small limitation here. And if I go like Unicode stress, like this is the Unicode file I use for for everything, and it renders like super fast, right? Like, and this is a look. Each one of these glyphs are doing a lookup into that map to figure out what that glyph is, and make sure that it extracts the right like UV coordinates to present to the screen, and like that's how it ends up getting all this fun stuff. And so now we can look at our glyph map, and like it's a lot more stuff, right? And it's just, these are just new inserts into that map. But yeah, this is the text file I use for like stress testing the Unicode implementation. And again, we're still getting our 240 FPS because if you do things just in a kind of, somewhat smart way and like a little bit intuitively, you just get good performance because you don't write trash code, right?
Somebody, Raiken, suggested in the chat that if you make the text yellow, the Unicode map, and if you add a little bit of animation, it will be almost like a Star Wars movie opening.
Oh yeah, if you can kind of like lean it in towards the screen too, you can probably like translate it. Yeah, that would be kind of fun.
Feature request. Nice. I think we got on a tangent when we were looking at the thread pool. Then we went to the implementations, OS specific things, and then data structures, right?
Yeah. Okay. So we explained, like, we gave an example of how to use like the thread pool a little bit, like by this example of like chunking up stuff. So there's our fun little thread pool, and the clipboard manager is the thing that was interacting with that whole HTML stuff that I was talking about earlier. Let's see. The atlas is the thing that is the glyph generator. So that's what's responsible for creating this fun thing. There's only one of those for now. I probably need to have multiple atlases for like different font. Like if you want to have bold text or you want to have like italicized text and all that stuff, all you would need is different atlases to track that kind of stuff. So we have clipboard manager, the undo graph, which is the thing here, right? That's this guy. That's this widget right here. That thing is responsible for taking the two text buffer snapshots, performing the Myers diff on them, and then like rendering that out to the screen. And then giving you like a UI around it so you can like, look at the whole thing. And then plugin manager is the other fun piece. I kind of want to like show the plugin manager a tiny bit just because it's so weird, right? You're literally invoking TCC to compile this C file for you. And TCC does a very cool thing where it has this capability to emit an executable code page, which you map into memory. You take that executable code page, you map it in, and then you can literally invoke C functions on that thing. And as long as you know kind of like roughly what you're looking for, then you have no problem in like finding the functions that you care about.
So,
but of course,
my suggestion is that we pick a system, which I think Plugin Manager would be a great candidate. We take a look at this in depth, and then we'll need to like looking at the time. Like we'll probably need to like step back, do a bit of like general questions about the project, and then probably some Q&A. So
yeah,
if you think Plugin Manager would be a nice one to dive into, we can do it.
Yeah, I think Plugin Manager is cool because it kind of gives you an overview of like because it ties into the buffer management system and it ties into like how TCC is involved with this stuff. By the way, I do want to quickly show the like paneling system.
Yeah.
That's a piece of rendering people are kind of interested in. So like you can just keep creating these panel things and closing them. But the other thing you can do is like you can attach panels to like different areas here, and you can like resize them and all that fun stuff. So like you have a lot of, if you double click it, by the way, it goes to the 50% mark. So you get a lot of flexibility in like what you can do with the different panels. And like if you have you can hit Control Enter to like open it to the side like that. But anyway, the paneling system is directly stolen from Ryan Fleury, by the way. Very much huge thank you to him for the code on that fun thing. It's a very once you have something like that in your editor, you just can't live without it. It's super, super nice for navigating code. Okay. Let's talk about the plugin manager. So the first thing that you end up having is that you have like this plugin API thing, which in order to call functions from what TCC emits, to call functions back and forth, you kind of have to have a C API to do that. And so this plugin API is designed to be like that C interop layer between to and from
Okay.
the plugin system. And so because you're accessing stuff directly in Fred, like the arena APIs, you get full access to all the arenas that you have in the plugins that Fred has to all of its arenas. So you get the same exact API.
So from
basically.
a plugin, you're not like sandboxed. You get
Yeah,
all
no,
of it.
you get full control. You get the whole hog whenever you start writing a plugin, right? Like if you want to explode the system or like investigate Fred internals, go for it. You know, I'm not stopping you. You can totally go for it. And I don't care about CVEs, right? Like it's this is all for like this is all for educational and useful purposes. Like, I don't care about that kind of stuff. But in general, it tries to be a little bit safe. As long as you stay within like the guardrails of the API, you're totally fine. So like this is the C API that plugs into that stuff. So if I wanted to have like in our little Wookash is awesome, we can also do like feed let's queue like an error and say like let's see. Let me make sure. Let me refresh my idea on what the message is. Okay, cool. Great literal. Something like that, right? So now whenever we recompile, oops. So we go recompile. So now whenever we insert our Wookash is awesome, we should see like a little feed message down here. So, oops, right? You get access to the feed and stuff like that as well. So you get access to like a lot of Fred specific stuff inside of the plugin API. It's like, that's what this is doing. That's what this is doing. And then batch editing is the thing that makes it possible to have edits be extremely efficient, right? So you start a batch, you do a whole bunch of edits, and then you complete the batch. And that also gives you two things. One, it makes the edit itself efficient, but it also gives you a single undo point. So like if you want to undo that batch, all you hit is Control Z and it's done. That's great. And then pushing general editor commands and stuff like that. So the API itself is kind of broken up. Like you have plugin API.dat. It's like literally this giant text file. Are you familiar with like what X macros are? But okay,
No.
I'm going to assume nobody's familiar with X macros. X macros are this really cool pattern.
Okay.
I say really cool because it's extremely useful and I use it all the time. Where in C, if you have like in C, when you have something like define X, A, B, C, you know, you could do something like A, B, and C, right? This just takes those three arguments and makes a string out of them, like whatever they happen to be, and then just concatenates them together. That's all this is doing.
Really?
Or we can even do something stupid like F of A, B, C, right? Something like that. Doesn't matter. But the point is, what the X macro thing is doing is whenever you want to call this, you call it with A, B, C, just like that. What an X macro file is it takes this idea and just makes an entire file out of that kind of stuff. So if I have like X, A, B, C, and I have like X, F, right? So on and so forth, right? Blah, 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 blah. You can have a whole bunch of them. But you have a whole file of this stuff. And so whenever, like, let's say this is, x.dat, something like that. That's the name of the file. And so when you use it in a C++ file or a C file, you do something like define like X and then A, B, C, right? And then you call like, I don't know, A, B, C. Let's get rid of that. And then you do something like found include x.dat. And what this does is it literally expands all of those macros in place, right? Because it's going to take the textual representation of these things and paste it in here. So now this becomes this. And now your macro activates, and then you end up calling G for all of these things.
Whoa.
So this is literally replaced.
From a
this
file.
is literally replaced with G like that.
That's the include system used in a way that's scary. That's like that's the dat file that was supposed to be code, but was not the code. It was text, but then you put it in the macro, and now it's actually code again.
Yeah, exactly. So you just keep like reusing the same file again and again. And it's like extreme, like it's kind of gross, but also extremely useful at the same time because it allows me to write the API once in one place and then like use it all over the place. So if I'm looking at this file is just a dat file. So like imagine these are macros, right? Yeah. These are all macros that expand to something, whatever I happen to define them to be. They could even be nothing if I want them to be. And they take some number of arguments, and then they expand into something useful.
Okay.
So if you want to see tool CPP, you can see me using this stuff. So like here's me defining what these macros mean, right? And then I do ed command. That's plugin dat. Okay, here. This is the better one. So I define these huge macros, right? These massive macros for like dat fun or dat separator, right? This is eventually going to end up creating the C API file that I embed in Fred. And then you just do hash include that stuff.
Yeah.
And then you can undefine them. It's good hygiene to undefine them, but you don't have to.
Okay, but this would be this one place where you use them. And I'm assuming you go through this exercise because you have another place when you're using this, right?
Exactly. So if I go to pluginmanager.cpp, plugin API.dat, so here's the other place that it's used. And this is defined differently because I want to be able to do something like TCC add symbol. This gives me the ability to kind of like call into the TCC functions or like the functions that TCC, the small C compiler, is going to generate for us. And so I take all of these functions and I like say, hey, I have a function inside Fred that has this name. And then that's all I need that for. And then I do plugin dat.
You know, I heard that like C survived so many years because it has this macro system and it's quite extensible. And this is the first time I start to feel this, you know? Like this is the first time when I'm feeling it because it was always like a thing that I had. It's like, yeah, sure. Yeah. Macros. Yeah. String replacement. And now when I think through what is happening, it's like, whoa.
Yeah. It's literally kind of like reflection in a way, right? Like you have this kind of like database of types and stuff. And then all you're doing is like you're reflecting over that stuff and pulling out the pieces that you care about and making other things out of it like this.
Wow.
And of course, like this isn't the only way to do this. You know, Ryan and Alan have like Metadesk, which is probably a better way of maybe doing this kind of stuff. But this way it lets me not have like a separate tool on top of like the asset tool that I have for generating all this stuff.
Okay.
Yeah. So there's plugin manager. So that's pretty much all we end up doing.
Can we talk a little bit about TCC? How does it work? Because I can understand the concept of when I will have a DLL and I have a running process, I can do during the process is running, do the execution, I can add a DLL. Now it's like there, right? So this is during runtime. But the TCC thing is like, oh, you just point it to a file and everything happens. Is it happening through the normal DLL system? What's going on?
There's no DLL involved, which is actually amazing. And that's why it works on Linux and Windows. So it works without any DLLs, without anything like that. So the idea is that you have like your plugin.c, right? You run this thing through TCC, and TCC ends up generating something like an executable code page, which is like blob, blob of bytes. And in this blob of bytes is going to be certain functions that have been compiled to x86 assembly. So this blob of bytes looks something like, ASM, like maybe it'll be like, I don't know, like it'll have like move instructions, it'll have like, call instructions and stuff like that. It'll have jump points like function, something like that. It's just going to be x86 assembly that's mapped to this thing called an executable code page, which lets you basically just call into functions that exist there. So think of it like whenever the OS maps your program into memory, it's just creating like a very safe executable code page where it takes the exe and it dumps it into memory, and like all that stuff is executable, right? And that's how you can call functions in your own program. TCC is taking that idea and just moving it to the runtime. So we create another region of memory that is also executable. And so as long as you know where the functions are inside of that code page, you can take that offset and use a C calling convention and invoke that function and just start running all of the executable code there.
An operating system allows you to do that?
Yes, it does. You can disable it, but it does let you do this.
Okay.
So on Linux, we actually ran into this where somebody was using a version of Linux that has the executable code page bit turned off. So they can't use the plugin system. But then Fred will just be like, sorry, I can't do that. I can't create an executable code page. You don't get to use plugins, which is totally fine. So they can conditionally turn it off if they wanted to. But by default, the operating system just lets you do that.
Okay.
Yeah. But that's the idea. And so the question then becomes, how do you know which functions to call? And that's where this thing comes into play, right? Like wherever we have all these plugins, like let's say I go modify this thing, that's where this thing comes into fall, because you as a user know what functions you want to invoke. And so like it's described by whatever this name is. So if I go back to our Wookash is awesome. So we knew the function was named Wookash. And so if we look at plugin.c, so we named our function Wookash here.
Yeah.
And that's what this editor hook thing does. So it's like the UI name, the description, and then the function name. So the UI name is this thing here. And so if I hover over it like this, it writes Wookash is awesome, and it's bound to the function Wookash, right?
Yeah. Okay.
That's how you know how all those.
And then you scan through this page produced by TCC, and you find Wookash, so you know the offset, so you know what to call.
Yeah.
Okay.
So TCC gives you this ability to kind of do this thing right here. TCC get symbol. TCC get symbol is a way of requesting offsets inside of that executable code page, because it knows what functions it generates and where that executable code is. So as long as you know what function you're querying for, you can say, hey, TCC, go find this function, the name of this function, give me that offset, and then I can call into that because I know what arguments that function is accepting. So it's basically, it turns into like this very scary reinterpret cast, but who cares? Right? Like, you know what you're doing.
Damn.
And then you set up your binding, and then eventually you connect to, this is if the binding is null, but eventually you connect
Danger
to the function,
zone.
right? The function.
Danger zone.
Yeah, exactly. This is the danger zone. It's if you're familiar with Archer, if you've ever seen that show, it's the danger zone reference.
Okay.
Yeah.
But yeah. I also like that you're, not bothering with CVEs, meaning like, hey guys, like, you want to use it? It's your responsibility. And then like whole host of solutions become available, because now you're like,
yeah,
That's my
exactly.
cabin.
Like,
You know, I'm doing whatever I want because it's my cabin.
yeah, as long as we treat programmers like adults, you can do really fun stuff, right? I actually think we ended up losing a lot of really fun programming opportunities with stuff like, I don't know, like speculative, like spec, all that kind of stuff. When those started breaking, programming got a lot less fun because then you have to start thinking about vulnerabilities and I'd rather just make fun stuff that is super cool and does really useful productivity things.
All right. I think that's we're nearing like 3 hours of the stream.
Yeah.
I think we can go, we can end the screen share part. I have a couple of questions like regarding the direction of the project itself. And we already have a couple of questions in our like Q&A app. And if people are interested in asking their questions, I'm going to paste the link again. You can throw the questions in there and you can upvote them. And so for me, the question is, what are you going to do with Fred? Like, what's the goal? What's the direction? Is this a product at some point going to be a product that you release? Is it a toy? Like, how do you think about it? Because it's like you spend, I'm not going to throw in it. Okay, you spend like months of hard work, like, combining all the hours into crafting this. So what's the end goal of it?
Yeah, that's the am I giving you feedback again, by the way? Are you getting a ton of feedback?
1, 2, 3, 1, 2, 3. No, I don't think so.
Okay, cool. All right. So what is the goal? And honestly, like, I don't really even know. I think the big thing that I want Fred to be is I want Fred to be like really accessible. So I initially started with the idea, like, maybe if I was going to sell Fred in any capacity, it would be super cheap. Like, it needs to be accessible, like $5 or something dumb like that. Because honestly, I don't really even need I don't need the income from such a thing. It's just kind of like a cool feeling, like, hey, someone paid for my product, and that's awesome. But I'm more leaning towards the idea of getting to the point where Fred is stable enough to where I can give people like a download link for it. And if they want to optionally donate, they can totally do that, as a gesture of good faith, like, hey, keep working on this. And I think it's super awesome because I use it all the time. That's the idea I'm more or less leaning towards, because it's the type of thing where there's editors that are better than Fred. But Fred has a particular brand of editing that I think no other editor really captures super well, at least for me. So, if you want the Fred brand, you can totally go for it, and it'll be free. And if you want to donate, you can totally do that and do all the weird stuff inside Fred.
All the weird plugins.
Yeah.
What is then your like schedule of working on it? Is it like a hobby after hours thing, or is it like, hey, I devote this many hours weekly and I'm like sticking to a schedule? Like, where do you land?
It's very much a kind of a hobby thing, because I do have a full-time job, and then on top of that, like, my wife and I just had a baby, so I have like that block of time that I have to dedicate to that. So it's like the amount of time that I get to dedicate to Fred is like gradually starting to dwindle a little bit.
Yeah.
But I really still want to dedicate as much time as I possibly can. So anytime, if it's late at night and I don't have a lot to do, I'll just end up working on Fred stuff and making incremental progress towards the project system and all that stuff, and go to definition and figuring out more stuff to do with Tree Sitter. So it's definitely in the hobby realm, which is why I keep telling people in my Discord, like, hey, every time I push an update, it's super awesome. I'm sorry they're so like infrequent. I probably update Fred maybe once or twice a month now. But it's frequent enough to where I get around to user feedback, especially if somebody reports a bug or like a feature that is really important for them. I really try to pay attention to that kind of stuff.
Okay. do you then consider because Fred is closed source, even though in the plugin system you get to see a part of it, do you then consider making it, I'm not saying you should, but like, do you consider a future where you make it open source and you have like people to contribute feedback directly, like, or through pull requests? And like, now given AI situation, it's like another thing to consider whether it even makes sense to do it. But do you see this as a path or not at all?
That's a good question, because I really don't know. The buffer itself is already open source, so anybody can use Fred buff if they want for their own projects. It even has the arena version on my GitHub. But the editor itself, I don't know. I feel like I've invested so much of my own time into that. Kind of open sourcing it feels like, man, I just I just kind of like gave people, I don't know. In some ways it feels like I'm violating a little bit of my own ideas, because then it's like, hey, everybody has access to all the ideas that I had for Fred, and like nothing's sacred anymore and that kind of stuff. But on the other hand, like maybe that just doesn't matter.
Yeah.
I think maybe it might get to the point where I do something like what Alan did and have, it be closed source for a few years, and then eventually I just like open source it because it's like whatever, right?
All right.
Yeah.
I have a couple of questions from the audience. Couple meaning I see 8. And I think they're coming in. So one major question, which is also on my mind. Why use C++ instead of plain C? What are the libraries or features that were missing in C?
Yeah, that is a really good question, because even the libraries that I'm using are all C libraries. So what am I actually getting out of C++? And the big things for me, and they're actually pretty big things, are not operator overloading, function overloading. Because I almost never use operator overloading. I think it's a fine feature, but it's kind of hard to wrangle. Like once you integrate it, it's all over the place, and then you don't want it anymore. But function overloading kind of makes a lot of sense. You have like a named thing that has like certain parameters that don't matter. But I also really, really like stuff like strong enums, like strongly typed enums. And maybe you saw that all over the place in Fred when we were going through it, but I have like enum class blah, like enum class blah. I think that kind of type safety is so critical to getting the orders of like parameters and arguments and function structure fields correct, that feature alone is worth using C++ for me. I honestly don't care that much about namespaces. I don't care that much about constref. I super hate immutable references in C++. I think it's single-handedly the worst feature in all of C++. If I had to eliminate a feature from C++, it would be that, because it causes so many bugs. But yeah, that is really bad. But also templates. Like templates can be very, very helpful if you use them minimally and you use them intentionally. So there's some cases where like you actually get a significant runtime difference between using a template versus like maybe a macro or like a C style thing where you have to use void star. If the optimizer has full view into like all the types and like all of the functions that are coming into that thing, it can optimize functions that would be impossible to optimize in C. That's the kind of stuff that I really enjoy about C++. And then there's some like ergonomic things, like auto is kind of useful in some very specific cases and stuff like that. But otherwise, I could eventually port Fred to C at this point because I'm using so little C++.
Yeah, I think this would be like a major rewrite, right? Like kind of, it's already there.
Yeah, it wouldn't be that bad. Like the vast majority of the functions wouldn't even need to change.
Is there something special in the memory management or the functional data structures you showed in the undo redo history?
Is there something special about them? I guess maybe we should have gone over that in the Fred demo, but like there's nothing really super special about them. So the way that this functional data structure works is like if you make a change to it, all you really get is you get a new version of that data structure. And you would think like that is super heavy, like you're copying all the text. Well, no, you aren't. Like there's this backing thing behind the data structure, like the immutable pieces that actually don't change. So the only thing that actually changes when you make edits to the text is for inserts specifically, is that you're inserting a new character into this append only text buffer. And that's really important because that append only text buffer guarantees that any previous snapshots that you took of the text won't be mutilated or messed up or something like that. So if you have an old view of this of the text and you keep appending to that same thing, and again, because of the guarantees that I have around arenas, those old views are still valid. Like those can be on threads for like days and you can still keep modifying the text, right? Like that is the useful thing about these about these functional data structures. And then the thing that becomes the view over the text is this red-black tree. So you have a red-black tree that tells you what spans of that immutable buffer you're kind of like looking at any given point. So like say you have offset like 50 to 500. Offset 50 to 500 is like this slice of that immutable text buffer. And then from like 501 to 1000 is like this slice of the text buffer. So it like keeps moving around. But that's kind of the idea. So this red-black tree is really the thing that becomes like your mini string views into this guy. And that's the way deletions work too. All they're doing is like, they're just taking that tree. They don't change the immutable text buffer at all. They just take that tree and like reduce the regions. Yeah. Or split them.
Oh, they modify the tree.
Yeah.
Okay.
Or they produce a new tree. They take the old tree and they change the nodes at like the children and then give you that new tree. Because the vast majority of the tree can be reused because it's all like ref counted.
Okay.
Yeah.
In the CRT effect, how does the UI figures the widget position since you're applying a post-processing effect in the GPU?
The way that the UI figures out the new widget position after you apply like the vignette effect is the UI doesn't figure out the position. it literally doesn't care. It doesn't do any offsets or anything like that. It probably should, but that effect is like, it's a post-processing effect that is, it's fun if you want to like mess around, but it's not meant to be used like super seriously, especially the vignette one, because it does like warp the screen itself. So your cursor position your mouse position won't be exactly what you think. It'll be off by a couple of pixels once you get to those corners. But the UI doesn't try to compensate for that at all. It probably could, but...
So in a plugin, everybody needs to be concerned about putting widgets in the corners, because for majority of users, they will have definitely CRT on, and these widgets will be like unclickable because it's like right in the corner.
Just put the useless ones in the corners. That's fine, right?
Put the ones that you don't want to be clicked.
Yeah, exactly. So to answer the question, it doesn't do anything fancy. It probably could, but it doesn't.
How to start an app so fast? Do you carry out any initializations after the window opens?
I do. And the way you wrangle all of that stuff is you offload as much as you can to threads. So like in the Fred startup, whenever you construct some of those objects, it'll take some of those objects and like take the work that they're doing and put it onto a background thread. This is actually something I stole from File Pilot when I hesitate to say his name,
Vyacheslav. Yeah,
Vyacheslav. There you go. Yeah, he was explaining how File Pilot works at BSCC, the Better Software Conference. And he said that he just throws a whole bunch of stuff on the background thread, right? I was like, I could totally do that. Like, that's so easy. Yeah, just throw all the initialization that you can on the background thread and let Windows do its stupid slow startup thing with OpenGL and everything else. By the time it comes back, everything will be together and it will start up super quick, right? So that's how I keep it low.
So you put the slow OpenGL startup and a font initialization and everything. Is this happening on the main thread or is it happening in the...
Yeah.
Okay. And everything else is happening on the background thread. Okay.
Exactly. So stuff like initializing, well actually the font rasterization doesn't have to happen right away, but you can set up the font map. So like you can load free type and you can start figuring out what glyphs you need and like all the sizes for the ASCII glyphs right away. You don't need OpenGL for that. So I do that on the background thread. And then for the actual rasterization where you need to create the texture itself, that you still need to synchronize with the main thread. So that happens a little bit later. But things like setting up widget state, setting up buffer state, setting up like the file tracker stuff and the plugin manager that does the compilation of the plugin itself, that can all be on the background thread. But TCC is so dang fast, like I don't even think it matters. It literally compiles that whole huge C file in a millisecond. Like it's well within frame time.
Can you save the diff tree for later use? Does relaunching the editor retain this tree?
The answer right now is no, it does not retain them. What I want to do in the future is basically whenever you close the editor, I want it to kind of serialize all the diffs out to disk or something like that. This is going to come with the Fred project because this is another piece that I have to solve for Fred Proj, which is that you want to have like all that undo state. So the best way to do it is to take like textual diffs from when you were from the beginning to where you are now and serialize that all out to disk so you can replay them when you open up the editor. And that should be a pretty straightforward thing to do. But to answer your question right now, it does not do that. It just kind of throws away the undo graph.
How come your window has no black edges when resizing despite using the GPU for rendering? Do you call into direct composition? But you said you're using OpenGL, right?
Yes, I'm using OpenGL. So like when I resize the whole window itself.
Yeah.
Yeah, so that is actually a tricky thing to get right. The way you fix that problem, and I haven't even really fixed it for Linux. Linux still has some weirdness to it. But when you do it for Windows, you wait for the event like WM size and WM paint. And what you do is you catch those two events and you see if the window size has changed. And if the window size did change, that tells you have to go and present the window again. So what I have is I have a call in those specific events. I have a call to the render core function, which literally just does all of the layout and everything. It's the resize render core function. And it says like, oh, okay, I'm going to compare the sizes that I have cached to the ones that you just gave me. If they're different, I'm going to destroy the old frame buffer and recreate the frame buffer with this new size. And then I'm going to go through and render a frame. And that's how you get like that nice like resize functionality, like as you're resizing the window.
Nice.
It's pretty simple, but like if you're not set up for it, it'll definitely mess you up. And SDL, the library SDL, actually had to put a hack into it to make sure that they can let you do this. But it also doesn't work on Linux, so I wrote my own.
How long did it take you when developing Thread to be good enough to start using it as your main editor?
That is a good question. I'd say that once I had incremental search working really well, I could start using it as my main editor. Because without incremental search, you can't do basically anything. And so like that is an absolutely critical thing to have. And I had that working within the first year. So back in 2023, when Fred was just a baby and didn't even have Fred buff, I was able to use it at work like pretty effectively because of that. And the incremental search back then kind of worked similarly to how it does today. So it like kind of chunks up the buffer and then sends it out to the threads, and then they start searching over their chunks and stuff. But yeah, after you have that, everything becomes much easier. And then everything you add on top of that just makes Fred way more usable. Like the whole anchoring to a specific directory, so you can like fuzzy search over all of the text files. Like that's the same thing File Pilot has when you turn on like the folder search thing. That is such an incredibly useful feature. And like Fred just has that built in now, which is amazing. And then the find all function that I just added to Fred, that is a huge productivity booster. Like that kind of, in a lot of ways, that makes go-to definition, not having go-to definition, a little bit more tolerable.
For dynamic lists, do you prefer using arena per array or linked lists where you can mix multiple lists per arena? And any thoughts related to indexes versus pointers related to this?
Yeah, so anytime I need like a dynamic array, I almost always use a linked list, because the only time you actually need an arena or you need an array for something like that is when you need to quickly sort it, because sorting linked lists is kind of a pain in the butt. But for anything else, I just create like a small linked list at like a singularly linked list, so you have like minimal overhead with each the size of each element. And then you allocate those all together, and it's like you get almost the same performance as an array, as a array, because they're all contiguously located anyway. So like you're not even really losing that much performance by having the extra pointer there. It just like they're all cached together anyway. So I definitely prefer linked lists when you have arenas, but there are some cases where you absolutely need arrays and you need like indices into those arrays. So I very much prefer having indices to pointers, even though I know the vast majority of the pointers that I produce in Fred are stable. And that's because indices can also come with this like generation index thing, which lets you tell the rest of the system if that thing is stale or not. And that's an important invariant to maintain as well, because a pointer won't retain that information, but an index you can attach more information to.
And the last question is gonna make you furious. Okay, should be prepared. This is what we'll end on.
All right.
What are the reasons to use C instead of Lua for plugins other than one indexed arrays?
It was the one index array. It was like that was literally the straw that broke the camel's back. I wrote so many broken for loops in Lua when I started messing around with it, because I kept forgetting like one index one array. I mean, I should have just been using for range loops or something like that. But like Lua it just did not appeal to me in the same way that C did. And the other piece of using C that's like super useful is the fact that whenever you write a project in C, like you can reuse that code inside of a Fred plugin. So like the string stuff that I have inside of the plugins, like when you go to generate a new plugin, the string stuff is literally from code that I've written on other projects. And if you look at Professor Sill He's just another absolute goat of a programmer. Um, he actually took the Fred plugin system and he kind of stripped away like all my API layers, and then he added his own like code, his own C code from his other projects to help like him write more Fred plugins, which is like insane. That's just so cool, right? Like you can't do that with Lua. You just can't do that. But with C, you can totally do that. Like you can just hash include whatever in the heck you need. And eventually I want to get to the point where you can do things like load library from inside of a Fred plugin. So like let's say you want to write a network API, like on a keystroke, you hit a key and it like calls out to, I don't know, your LLM or whatever, and it generates a response, and like that's what you insert into your text buffer or something like that. And that's really how all of the modern editors integrate agent-like experiences anyway. But we could do that in Fred with just C, right? Like, make it happen.
Nice. Awesome.
Yeah.
Cameron, thank you so much for joining me and walking me through the project. This was awesome.
Yeah, absolutely. Thank you very much for the opportunity. And, I love your podcast. I love this stuff. And, I'll be here. I'm here for it.
Really happy that you joined. And both, like, it was really nice that we managed to go through the showcase Fred, and then from the user perspective, then go through the code, see cool parts of it. It was really nice.
Yeah, absolutely. And, check out the Fred server if you want to play around with Fred yourself and, give feedback and all
Join
that
the Discord server on how is it called? Like Fred Discord server? Is there a link?
So you can get to it from HTTPS. freddev.tech. So if you go there, you can there's a link to the Discord on that website, freddev.tech.
I'm putting it now in the chat.
Oh, okay.
As well.
Yeah. Oh, yeah. That's also a better way. Just having the direct link.
And I will put this in the description of the video as well. Nice.
Yeah, excellent.
Nice. Everybody, thank you for tuning in. This will be now available immediately for members in this like raw, unedited fashion. And then after a couple of weeks, it's going to be Easter. So it's like next month plus. I will reach out to you, Cameron, with like the edited version. After Cameron says, green light, let's go, we'll publish it.
Awesome. All right.
Cameron, please stay in the call because Riverside might still upload the thing, and I will be closing the stream. So goodbye, everybody.
Thanks everybody for tuning in.